25, everyone. Welcome back for the start of another year of Green Builder Media webinars. And we begin on National Hat Day, which I am clearly not observing. I guess I'm off to a bad start to my year. I'll try and do better next time. Today, though, we are going to talk about codes. Now, we're not going to talk in code. We're going to talk about codes, specifically the 2024 International Energy Conservation Code and the International Residential Code. We're going to look at the key elements of the latest version of the IECC with short detours into the new IRC, so you will feel much more confident designing, building, and inspecting to the latest code requirements. Now, we're joined by Darren Waschak, who is the president of Learning Edge LLC, a firm that specializes in residential energy efficiency training and building science consulting. Darren was a key implementer of the EPA's Energy Star for Homes program for more than 20 years. He has helped solve warranty issues for hundreds of homes and trained thousands of individuals on the basics of building science, energy efficiency for buildings, energy efficiency programs, and the IECC. He holds a bachelor's degree in construction and master's and doctoral degrees in public administration and policy from Arizona State University. That means he was probably cheering on the Sun Devils in the most recent college football playoff. If we're talking, that can only mean one thing. NV Energy is our sponsor. They have this wonderful tool called PowerShift by NV Energy. It helps residential and business customers conserve energy and save money on their power bills. PowerShift is a one-stop resource to find energy-efficient products and services. For more information, check it out at nvenergy.com/PowerShift. Now, during the course of today's presentation, you could submit questions for Darren. Simply use the questions box inside the GoToWebinar control panel. I'm going to review those questions and pose those to Darren after his presentation. All right, Darren, welcome to your Green Builder Media debut.
Thank you very much, Mike, and the rest of the Green Builder Media team for inviting me to speak. It's a real honor. The Green Builder Media group has been active for a long time, and you guys do a lot of excellent work and presentations. I've certainly seen lots of your presentations over time, so I'm excited to be able to do one of my own presentations for the Green Builder Media audience. Today's class, a high performance home master class, energy code mastery in the IECC 2024. This is a class that is brand new. I didn't develop it until August of last year when the ICC finally released the 2024 IECC version of that, and the IRC, the energy portion of the IRC. And so I was waiting last year to put this new class together, and finally in September I was able to do that. And up to that point I was sharing this similar information on the 2021 IECC. But very excited to be able to share with everybody what has changed, what's different. And I know with the IECC 2024 just being released, there's going to be some time before the municipalities start to adopt it. But I do know that there are several municipalities in the Arizona market where I am. They're already planning on rolling this out and adopting this standard this year. So that's pretty good. And usually it's that 1 year lag, especially this year with the 2024 version being longer or being a little bit later. We'll talk about why it was late. So what am I going to cover today? I'm going to talk first a little bit about background and history on code. Where have we been? Where are we? Where we're going? What's in the residential code? This is where we're going to dive into the meat of the content that's in the code. We're going to talk about the options for complying with the code. I talk about 9 ways to get in through the code, 9 different pathways, if you will, that you can comply with the code. And we're going to sort that out. There's more than that even, but we'll keep it to 9 today. And then lastly, we're going to talk about the tests and inspections that are required as part of the code because that is important. And most of the people that I talk to in my classes are going to be home builders, architects, building code officials, trade contractors, home energy raters, building inspectors, realtors. That's the people that are in my classes typically. And so there's a lot to share so that you're understanding what is in the code so that you can navigate that code, or when you run into it, you understand what it is you're looking at. So there's a workbook for today's class, and Mary is going to put that into the chat. So if everybody would go into chat, hit the link, you can download the workbook for today's class. It's fill in the blank. So as I go through, keep your ears open and your eyes peeled for filling in the blank for the answers. We just want to lock that information in. that we're covering today. So get that workbook downloaded, pull it up on another screen, print it out if you want to, and keep track as we go through today's material. Today's slides are going to be available to everybody. The only thing I ask is that when we get to the end of class, you're going to get a short feedback survey. It's just 3 quick questions. Fill out that feedback survey. When you're all done, you're going to get a link to download today's presentation slides. But you can't have the slides unless you give me some feedback. So that's our give and take when we get to the end. But rest assured, all this content that you see today, you'll have an opportunity to see that and get that. So kick back, focus on the workbook. So the codes that are put out by the ICC, the International Code Council, those are actually available for everybody for free on the ICC website. And there's the URL right there. And I do have several URLs in the back of the workbook and resources, I believe including this one, that you can click on. But actually you can get and look at all of the codes, the latest edition of the codes on the ICC website completely free. Now, they're very well locked down, so you can't print them, you can't highlight them. All you can do is probably screenshot them, or you can screenshot, but that's the best you can do. Of course, they would like you to purchase them, but they are available for you on the website. We're going to focus our attention almost exclusively on the IECC. That's what our class is about. But we are, as Mike said, we're going to do a couple of detours into the IRC, because there's things in the IRC that are directly relevant to building science and building energy efficient homes. So I will point that out as we go through the different sections of today's presentation. So most of you are probably aware that the codes have been developing basically since the 1970s is when the code started. We didn't see the first of the International Energy Conservation Code until 1998. So that was the first time that there was a code, and then basically 2000, 2 years later, they started the 3-year cycle every 3 years starting in the year 2000. And you can see how the code has become more and more stringent, or more energy efficient, if you will, calling for more efficiency over time. And so there was a steep incline in reduction or increase in the stringency to 2009 and 12. And so there was quite a bit of push. And then when we hit the Great Recession, everything kind of leveled out a little bit. And then in 2021, they kind of cranked up the party again. And you can see that this information shared from basically the Energy Codes Coalition, this graphic, they have a glide path to net zero that a lot of the codes are kind of working towards. And you can see that if you look at the Pacific Northwest Labs, their analysis that they do basically each time there's a new code. They just came out with their latest one in December. And you can see that the 21 code pushed us down towards this glide path to net zero. And then they about 7.8 national average, not local, but the national average they just came out with in December is about 7.8, maybe even overshooting a little bit the glide path, although whether this is to scale or not is a whole nother story, but it's about 7.8% better than the 2021 code, according to the PNNL. So one of the reasons why we had a delay in getting the 2024 IECC and last year was because there were a number of appeals that happened at the end of the calendar year in 2023. Normally they would have it wrapped up by the 31st of December, and then we'd have a brand new code for 2024, and that's how things have gone in the past. But there were a number of appeals dealing with electric readiness, EV charging readiness, efficient and resilient code requirements, stretch code appendices, as well as all electric appendices. So there was a lot of appeals and discussion. Well, the ICC board finally approved all of that, got through the appeals process in 2018, on March 18th. And then that's where in August, they finally released both the IECC and the energy section of the IRC, which I'll clarify in a moment. So going forward, I think to avoid this problem, what the ICC has talked about is a continuous maintenance process specifically for the IECC and Chapter 11 of the IRC, which is the IECC. So we'll come back to that here in a moment. The codes, in order to understand what you need to do inside the codes, you need to know what climate zone you're in. And so the climate zones follow the county lines, and the country is divided into 2 sections. Either the west part of the country, except for the coast, is climate zone B, so that's where the B comes from. And if you are east of that imaginary line down the middle of the country, you're going to be getting that designation of A, which is moist. And it's important to have those two designations because dealing with moisture versus a dry climate is going to make a big difference, of course, we know when it comes to building science and the performance of buildings. And so now let's take a second and talk about that differentiation between the IRC and the IECC. So Chapter 11 in the IRC is the IECC. So if you just wanted to buy one book, you could buy the IRC and you would have the IECC as well in Chapter 11. When you're in the IRC and you go to Chapter 11, one thing you'll notice is it cross-references back to the IECC. So that's where the parentheses come in. 401.2 would be that equivalent in the IECC. So that's how those two work together, but it's identical language. And it's one of the reasons why the IRC was delayed for a little while, and then finally they released the IRC except for Chapter 11. And that's why we saw the on the website, they said, except the energy section. Okay, so first off, let's talk about the sections of the code that apply directly to residential buildings. They need to comply with either 401, 21, 22, 23, or 24. These are the traditional pathways that are defined inside the code. So there's a prescriptive compliance option. There's a simulated building performance option. They added simulated this 2024 cycle because that's exactly what it is. It's the simulated or performance option. They also have the energy rating index option and the tropical climate region option. Those are the divisions within in the code, if you will, the pathways. We're going to actually subdivide this a little bit more because there's even more granularity than that. What I did want to point out to you is that the R408 section, which has to do with additional energy efficiency, many of you remember that was added in the 2021 code. That actually only applies now to the prescriptive path. So R408 only applies to the prescriptive. No longer does it apply to the R2.2 or the R405 simulated. In 2021, it did apply in part to both, but now only prescriptive. So the big thing that they added in the 21 code were these efficiency packages. So in other words, you got to meet the code, but then they want to juice it a little bit more and kind of push you down on your efficiency or increase your efficiency, whichever direction you choose to look at it. And so what they added in the 21 code were these efficiency packages, okay? And so the efficiency packages prior to the 2024, I'll show you what those packages were, and you basically needed to go through and pick a package and you were good to go. What they've done in the 24 code is they've added a whole lot more to this. So I'm going to spend some time on the packages, moving along, rapidly here so that we get through all of it today. I'm not going to dive into great detail, but I want to do an overview of the packages that are part of the 2024 code, because now what you're doing is you're accumulating points depending on which package you do and what climate zone you're in. So you've got to accumulate points, a total of 10, and you've got to pick it out of two different measures in that, and that will become a little more clear here in a moment. There is an exception if you are a really big home, 5,000 square feet or higher. Now what they're going to do is they're going to move you to 5 additional credits. So you're going to move from 10 to now 15 credits. You're going to need to work a little bit harder if you're in a larger home as an exception. So these are the paths or the packages, if you will, that were in the 21 code. Okay, so enhanced thermal envelope, more efficient HVAC equipment, performance, reduced energy use in your water heating, more efficient thermal distribution like your duct system and your air conditioning system, improved air sealing that also coupled with that improved ventilation. So that's where they stopped at in the 21 code. But in the 24 code, they added a whole lot more on. So what they did is they beefed up the number of package options that were available that you can see there. What I want to do is walk through each of these so that you guys have a feel for how does this work and how does this shake out in the 24 code. And I want to back up for just a moment and tell you that it's important for you to understand what's going on for these packages, especially if you're doing the prescriptive path. If you're not doing the prescriptive path, then everything I'm going to share with you right now, you really don't need to worry about. But there are a fair number of people that still do the prescriptive path. And so picking these packages is essential. And so we want to make sure that you're comfortable with what these are and how they operate. So one of the things they did in the 24 code is they decided to take the tables and turn them. So most of you remember that the tables up to the 21 code had the climate zones down the left side, okay? And then they put the different options across the horizontal axis across the top. Well, for I think good reason, and it makes sense, what they did is they inverted that so that now what we're talking about is climate zones across the top, and the whatever content they're trying to get you is going down the left side. But this is also where I told you you need to know what climate zone you're in order to determine what to do in the code, especially the prescriptive path, of course. You got to know, depending on where you are, you're going to need to know what to do. Now, notice that not all of the climate zones will get credit for the different options. So this is reduced total thermal conductance in this particular, in the table. This is the first one that's up in the big long table that now is in the code. And so if you're in climate 0, 1, 2, or 3, you're not going to get any credit for doing less than or equal to 2.5% reduction in your total thermal conductance. But you will get credit in the colder zone. So again, you got to refer back to this table, and I'm not going to look at this table. I'm going to maybe peek at it a few more times today, but I wanted you guys to know that depending on what climate zone you're in, it will define how many points you'll get within each of the categories. Okay, so the first package is enhanced building thermal envelope options. And one of the things they added in the 24 code that's new is they added this term that I've already thrown out to you, which is thermal conductance. So we haven't seen thermal conductance, but it is now defined in the code. And you can see that definition over on the right-hand side. Normally we think of U values and thermal performance, but now they've added in another term that we're going to see throughout now the code that we need to be familiar with, and that is C factor or thermal conductance. So you'll see that as we move forward. I just showed you this table. Depending on what you can do to reduce or increase the performance of your shell, your envelope, the thermal conductance of your envelope, depending on what climate zone you're in, you're going to be able to get points. And remember, we got to get 10 points in at least 2 categories if we're in the prescriptive path. All right, so we got to get, that's what our objective is, and you start accumulating your points throughout the table. And this is one package for the first set of options. Next is enhanced building thermal envelope, improved fenestration. So the last one was improving your thermal envelope, your insulation values, and your shell. The next one is doing something to your windows. So now you can see that depending on what you do in climate zones 1, 2, 3, and 4, it'll define what you do over on the right-hand side for your windows. So what do you need for the U factor and the SHGC on your windows? Now, the next option for under thermal envelope options is roof solar reflectance index. So now if you do something on your roof in order to make it have greater reflectivity, which is again lighter colors, you can see that now you can get points in this category if you choose to. So I'm not going to spend a lot of time. You guys will get the slides and you can see the highlights as we go through. Next is reduced air leakage. So in your thermal envelope, if you reduce your envelope leakage to not less than 2. Notice that they're not wanting you to be, this is new, I haven't seen this before, they're actually putting a floor on there. It used to be just don't be any leakier than 3 air changes per hour, 5 air changes per hour. But now what they've done is they said, yeah, no more than 2.5, but we also don't want you to be tighter than 2. So that's one of the things they've done is they put a little floor on there so that your building will actually still have some leaks. So that's new. Haven't seen that before the code and what it's doing. They have an alternative of 0.24 cubic feet per minute per square foot of your shell. So you can alternatively calculate the area of your shell, and 24% of that area would give you your blower door number, your CFM50 blower door number. More efficient HVAC equipment. So this is the second package or the second option of packages. So what can we do for more efficient equipment? So there's a lot of detail here. You can do option applicable by climate zone. So depending on what climate zone you're in, you're going to be, well, the first one's all climate zones, I'm sorry. So depending on what you do, you're going to be able to get points. Then we've got certain options that are applicable only in your warmer climates, 1 through 3. They have options that are applicable 4 through 8. And then more efficient HVAC equipment for climate zone 4 alone. They do have a specific option for that. So again, we could spend an entire day going through these packages in minute detail, telling you what all those options are for 0, 1, 2, and 3, but you guys can read the code for that. I want you guys to know what's in the code and make sure that you walk away today going, okay, now I understand what I'm dealing with, this new beast called the 2024 IECC. And so you guys can spend more time looking into that on your own time and understand this package. And remember, again, it's if you're doing prescriptive path. If you're doing performance path, which quite frankly, most builders will do, then you're not going to even worry about this stuff anyway. Okay, let's talk about the next package, reduced energy use in your water heating. So this is one of those packages that existed before. And depending on what you do, you can look through this options and different measure numbers and different efficiencies. They're going to lead to different points within the table. So you refer back to the table if you want to do any one of these, and it will tell you what points you're going to get for the defined water efficiency, hot water heating efficiency. Next is compact hot water distribution system options. So within the service water heating, if you are able to create a more compact plumbing, so you can see the illustration on the right, basically if instead of trying to feed the water to the other side of the house, instead they put in a second water heater, tankless in this case. And so now the run from the water heater to any one of the fixtures is going to be close, much closer. In fact, the definition is not more than 16 ounces of water being stored. Okay, so that's actually a pretty small number. That's 1/8 of a gallon. Some of you might be familiar with the WaterSense program and even Zero Energy Ready. They have also parameters, requirements for keeping our water wasting of water as low as possible, which also translates into our hot water not having to heat our water as much. But that is a half gallon, okay? That's a half gallon of water. So you have to be able to get a half gallon of water at the furthest tap. It has to rise usually 10 degrees is the definition that WaterSense usually uses. So, but you've got a half a gallon of pipe volume in order to get that 10-degree rise. But they're doing a straight up 1/8 of a gallon or 16 ounces here. So keep that in mind. It's a little bit different than what you're used to. I'm certainly used to when it comes to the other requirements and other energy programs. Where the source of the heating water is a circulation loop, demand recirculation water systems are required, which is great. In my water efficiency class that I teach, water efficiency and the water energy nexus, in that class, I actually spend more time on hot water recirculation systems and talking about where they are, the best way to install those in order to maximize water and energy efficiency. And a demand is it. So only when you're calling for that water do you want that water to be circulating and being delivered. And so they do in the code now do a demand recirculation system is what's required. And then a dedicated return loop is also required. You can certainly do systems, hot water recirculation systems that use the cold water line to send the water back to the water heater. But in this case, they want a dedicated in the code. They're going to want a dedicated line going back. More efficient thermal distribution systems. Now we're into the duct system. Okay, they've got definitions for either a ductless system or air handler ducts inside the conditioned space. You got to pick one of these options, by the way, not all of them. Air handler unit, not less than 80% of the ductwork is located inside the conditioned space. For ductwork located outside the conditioned space, they talk about what the leakage parameters are, no more than 2% or 1.75% leakage with and without the air handler. So they've defined what basically getting ducts into conditioned space looks like, and they've given you 4 options. And I cover a lot of this content, by the way, in my Unvented Attics class. I've got a whole class devoted to getting ducts in conditioned space, and so that's a great place where you can dive deeper into this if you're interested. Now, improved air sealing and efficient ventilation system options. So now we're talking about Again, these were all from the 21 code, but they've beefed these up quite a bit more and changed them for the 24 version. So again, you've got options here. Pick one of these, either an energy recovery ventilator or heat recovery ventilator, HRV, ERV, or less than or equal to 2 air changes per hour with an ERV or an HRV installed. So you can see, depending on what you're doing, you're going to get more points, of course. The tighter your envelope with the HRV and the ERV, again, the best ventilation is going to be from an HRV, ERV. And I love that the code starting in the 21 version has been adding in HRV and ERV. So we'll talk a little bit more about that here in a moment. Energy efficient appliances. This is another package that you can look at. Your clothes washer can be installed and more efficient, your refrigerator, dishwasher, all of it. And so here are the parameters that you would follow if you decide that you're going to be doing this package for the prescriptive path. Renewable energy. They have if you decide that you're going to do a permanently installed renewable energy in your project, in your home, you need 1 watt per square foot of floor area, and you'll be able to get points for this package. Demand response. This is also new. They've added in demand response thermostats. And what's neat about this is what they're trying to do, and the code is pushing, lots of things are pushing in the direction of allowing there to be bidirectional communication to our connected appliances, water heaters, program thermostats, pool pumps, EV chargers. If those can be in connection and allow for demand response, now we're into an area of virtual power plants, which is an exciting thing that we're now starting to see with the utility companies. And the code has now weighed in on this. The code is now allowing there to be, or saying there's a package where you can do demand response so that it will allow for voluntary participation in a utility provider demand response program. And by the way, Mike mentioned NV Energy. They have their Power Shift program. That is basically a demand response program where they are able to talk to and communicate with all the thermostats in the NV Energy area and send a signal to adjust that thermostat so that on a peak day in Las Vegas, when it's super hot and they know they're going to have a peak, they can send a signal out and then help to manage that demand by taking thermostats and adjusting them. Now, in those programs, I have to clarify, you can always override it. It's not as much Big Brother as you might think. You can override that if you don't like what's going on. But most of us are not at home and we're working in the houses during the peak. We're not there. So for most of the people, they're not going to override it, and that's a huge benefit for shaving the peaks off of our demand curves. And that's all part of this idea of virtual power plants. Again, I have a whole class on that one too that I just rolled out because that's such a fun subject. But this is where the code gets involved in that. Okay. Let's talk about opaque walls. So for opaque walls in climate zones 4 and 5, they talk about a maximum U factor. They talk about for wood frame walls, what you can do. They talk about primary space heating is provided by a heat pump. So if you follow all these parameters, you go back to the table and there's an opportunity for you to get points. Remember, we're targeting 10 within 2 different packages. You can take advantage and comply. So now what can we do to make our opaque walls better? And by the way, this U factor is an increase basically from 0.045. So what they're allowing you to do is to take your U factor for your climate zones 4 and 5, and you can actually do a wall that's not quite as efficient, right? Lower is better on U factor, and so it's a 0.45 normally, but you can increase it to 0.6 as long as you do a heat pump. You do a water heater, heat pump, water heater, heat pump on your system. 3 additional credits also in another category. This is just giving flexibility, right? If you can't quite get your envelope to be at the 0.045, this will allow you to have another option. Whole home lighting controls, right? So they've got, if you put in whole home lighting controls, there's an opportunity for you to get credits that way. Higher efficiency lighting, okay? If you're installing, all spaces shall be provided with hardwired lighting with lamp efficiencies of 90 lumens per watt or luminaires of efficiency of 55 lumens per watt. So this is a way of incentivizing putting in more efficient light fixtures. And you can see when you go back to the table, though, a little bit of a head scratcher. I'm not sure that I quite understand this, but if you decide to do high efficiency lighting 408-211 like we're talking about here, unfortunately, there's no credits to be given. So I'm not sure why you would do it. And I was hoping that maybe when I went back to the code yesterday to see if they had updated, if this would change. But quite frankly, it's not. So I don't know why anyone would do 408-211 when you get 0 points for doing it. I guess it's a feel good. But I thought that was a little odd. But keep that in mind when you go into the code, you'll see this. All right. So those are the packages. That was the last of the packages. I just wanted to give you guys a highlight so you knew what was in there. We had some original ones. They've beefed those up and they've added in a bunch more packages. And really, if you go and read the preface to the code, which I actually geeked out and did, they talk about how what they're trying to do with the 24 version of the code is create more flexibility, more options in order to comply with the code. And you can see in some ways they've actually been able to do that. So what I want to do now is I want to look at sections 402 to 404. We're going to look at some of the verbiage. We're not going to go through it page by page, line by line. I'll try to use as many pictures as I can. But I just want you guys to see the highlights of 402 to 404 and section 408. What is it that's in there that I think you should pay attention to? Now, when we're talking about this stuff applies to prescriptive specifically, all right? Hold that thought for a moment. The first one I want to talk about is 40221. A lot of people are not aware of this kind of hidden item in there. And that is that if you get your insulation in your attic over the top of your exterior walls, over the top plates, all the way out to the edge, then you're allowed in 40221 to lower the actual R value of your ceiling insulation. So you can see in 2018, in climate zones 1 through 3, the prescriptive table said R38. But if you get your insulation out over the top plates and you're fully out to the perimeter, they're going to allow you to reduce that on average to an R30. And if you're in climate zones 4 through 8, from 49 down to 38. Now, in the 21 code, one of the things they did was they said they followed the ill-suited, ill-defined concept of more is better, because more is not always better. And in 2021, what they did is they said, well, we got to keep pushing that glide path to net zero, so we got to throw more insulation somewhere. So let's go to 49 in climate zones 1 through 3. Well, I'll tell you, R49 in an attic in Phoenix, where I am, makes no sense at all, okay? Makes no sense at all. Yet, if you're prescriptive and you're in Phoenix, you got to do 49. And then in climate zone 4 through 8, you had to go to 60. Well, I'm happy to report, as you see already in my slide, that in the 2024 code, something that I've never seen happen before, and all the times I've been watching and teaching the code, they actually adjusted something backwards. So in the 24 code, we've dropped back to R38 and R49 in the 21 code, or back from what we had in the 18 code. Never seen that happen before, but in fact, let me tell you, I think the basis for that. Well, let me see here. I don't have my little chart here. I thought I had my chart. The problem is that it's law of diminishing returns. And I teach this in my building science class, is that as you continue to add insulation and add more and more thickness, you get this law of diminishing returns, okay? So that first little bit of insulation that you add, you get big benefits. But as you get from R30 to 49 to R60, you're at the bottom end of the curve, right? You're at the bottom end of the curve and it's really flat. So you're not getting much bang for the buck when you go from 30 to 38 to 49 or 60. You're just not getting as much bang for the buck. And so that's why I was super excited to hear that they had kind of gone back to the 2018 version. Okay, let's talk about the next one, 40224. This is for air permeable insulation, okay, like fiberglass or cellulose, not foam. For air permeable insulation in vented attics, a baffle needs to be installed, right? So we've got to install baffles so that when air comes in, an E-vent like this, the air will push over the top of the insulation, okay, instead of blowing that insulation back. Now, I want to point out that I added in here prescriptive because this 40224 applies to prescriptive, but this also applies to the performance in the ERI path, okay, 405 and 406. And but you need to know that one of the things they did back in the 21 code, and they've continued forward, is they've created in section 405 for the performance, they've created a table. And in that table, it will list the things that you need to do in sections 402 through 404. So it used to be that they would actually say mandatory or prescriptive. Well, in the 21 code, they actually put a table in there. So if you want to know what you have to do in section 405 out of the prescriptive requirements, you got to go to this table, okay? So for example, if 402.24 is listed in the table, and since it's listed in the table, that means you, in the 405, section 405, you've got to follow the 402.24 in the code. So I don't know if this made life easier or harder. I think the jury's out. They kept it for the 24 code, so maybe people didn't scream loud enough if it was a concern. But this is how you navigate the code now. You got to go into the table, and it'll tell you what to do. In the 406, it does the same thing. So in the ERI path, they have their own table, and in that table, it will tell you what you've got to do out of the prescriptive requirements, 402 to 404. Okay, so that's how you navigate the IECC when you're in 405 and 406. So what I will do now throughout is I will put in red if that section also applies to the ERI and the performance path. But back to this thing. If we have insulation that does not have a baffle in it, here's the events. What happens is eventually the air, the wind coming in will blow that insulation back. And then what we end up with is in the summertime, these smiles up there, this is what it looks like. And so this is why we need baffles, so that that air will come in and it won't push back the insulation. So we need baffles. And again, this is what they look like in order to make sure that that insulation does not get disturbed. Incidentally, on O'Hagan vents, that's the high vent and the low vent. On the low vent, you also need to baffle that because air can come in an O'Hagan vent and also push that insulation out. Then you got this nice hole below or around it, and that's not going to work. So on the low O'Hagan vent, you really should baffle that as well. That's a good thing for just good building science to do that. Attic hatches, okay? Attic access hatches and doors insulated to the same level as the surrounding insulation. So if you got R30 in your attic, that attic hatch, that little scuttle hole, that's got to be R30 as well. And I'll just tell you right now, gluing a fiberglass bat to a piece of drywall is not going to cut it. Okay, this is a perfect example of what I see all too often when I've been up in attics. They've glued the paper and the paper tears. Or let's just say you just did a great job of stapling it on there, gluing it on there. Remember, bats, they fall apart along their grain real easy. They tear apart super easy. So you just, that thing eventually from going up and down, that bat's going to be off on the side, never to be seen again. And of course, then we're going to have attic hatches in the summertime that look warm. So this is exactly what it looks like when you don't insulate with infrared, what it looks like when you don't insulate an attic hatch. So what we really need to be doing is putting a piece of foam on there, okay? So gluing a piece of foam onto that is going to give you your R value equivalent. This is a high density polyurethane foam. So we're going to get much more R value per inch. We don't need as much foam stacked on or glued on there, but that's the way to go. So this is another piece of the attic retention. The attic is the retention piece, okay? So in here we have, first off, weather stripping. So you've got to make sure you put weather stripping on your attic hatch. Typically, we recommend Q-Lon strip, okay? So this is going to be what we do on our vertical, on the doors that we do for our front doors and our exterior doors. Just take that, turn it sideways, and that's a vinyl strip that is far, far better than the lick and stick or peel and stick foam. That stuff doesn't last very long, but use the vinyl, and this is a great way to air seal. And then also an insulation dam. This is part of retention. This came up actually in the 21 code. They added it in. I really like it. It's the idea that we put retention on there so we can get our insulation right up to the scuttle hole at full depth. So whatever the depth of your insulation is, you need to make sure the dam's high enough to be able to retain it so it doesn't tail off as you get close to the hole. We can get full thickness right up to the door. They also added in that when you change ceiling heights within your attic, you're going to run into the same problem where the insulation will tail off right to the edge. Put a retention in there so we can get it all the way to full height, all the way out to the exterior. And then we have the same addition in the code, which happens to do with porches. So if your porch is not at the same elevation as your ceiling on the inside, if it were, they can just blow the insulation a little bit over the top of the porch, maybe 2 or 3 feet over, and we'll get full thickness before it tails off. But if there's a height change, we don't have that. So it's good building science. I love this, to put a dam in there so that we can get our full thickness, full height of insulation all the way out to the perimeter. Floor cavity insulation, okay? This is prescriptive only, by the way, prescriptive only. Permanent contact with the underside of the subfloor, right? So if we do insulate over unconditioned space, either a basement or a crawl space, or in this example, a garage, we need to make sure that insulation is up against the floor. However, the code does allow you to put that in contact with the ceiling of the garage in this case. You can do that, but what's critical is that you need to make sure that the perimeter is insulated. So if we've got a truss that's, say, 18-inch deep floor truss, and our insulation is 12 inches deep, okay, you got a 6-inch gap all the way around because that insulation doesn't go all the way, fill that entire cavity. So I love that they talk about ensuring that we get that perimeter insulated. And also, quite frankly, one of the very best ways to insulate your band joists between floors, or your rim joists on top of a foundation, as you see here, the best way to do that is with foam if you possibly can. Bats can fall out. Getting the loose fill to stay in there is tricky. The framing is tricky. Getting it up against the outside, which is your air barrier. And so, really, the best way to get band joists and rim joists is to blow them with foam if you can. I know you don't always have that on your job and your project. Do the best you can. But if you've got foam on your project, you definitely need to make sure that those rim and band joists are hit with that foam. If you got a truck out there, take advantage of that to get the very best way on those rim and band joists to get them done correctly. Basement walls, okay? This is climate zones 3 and higher. Basically, you got to follow what the table says. So if you're in climate zones 3 or higher and you go into table 40213, which we'll glimpse at here in a little bit, it'll define how much insulation you need. What we define here is how much, what that layout needs to be for the insulation. So it needs to be, if you've got, let me back up, I went a little too fast here. If it's an unconditioned basement, well, then you don't need to worry about your insulation down there. But if it's conditioned, if it's unconditioned basement and you've insulated your floor, then you can ignore it. But if you're not insulating the floor, you've got to make sure that your insulation goes down at least 10 feet below grade or to the floor, whichever is less. Slab edge insulation. All right, for slab edge insulation, this is actually a little bit of a change from the 21 code. And you can see here that what is a kind of a holdover from the 21 code is that if you are in climate zones 0 through 0, 1, and 2, you do not need slab edge insulation. In a hot climate like Phoenix, climate zone 2, you don't need that. But 3 and higher, you're going to have to put that in. Okay, what they added in to the 24 code is they made it clear that if you have a heated slab, no matter where you are, even in climate zone 0, 1, and 2, if you have a heated slab, you're going to need to put in a minimum insulation on your slab edge and under the full slab. Makes total sense. Ground is usually about 55 degrees. If you go down deep enough, it's about 55 degrees. So if the ground is colder than that heated slab, you're going to be constantly feeding that heat into the ground, which is not what you want. You want that heat to go into your building. And so it makes total sense that we insulate underneath our heated slabs, even in Phoenix, climate zone 2 or other places, because we don't want to be, again, warming the ground. We want to be warming our conditioned space. Okay, and this is just one of those details that I kind of ran through a little bit there, is that you can put it on the inside of the slab, as you can see here, nice chamfer cut so that we don't have this big gap on the perimeter of our slab, or you can run it on the outside. If you run it on the outside, it should not be exposed. This is a nice detail here. Ignore the disconnected downspout there, but the detail with the stucco on there, great detail for your slab edge insulation, making sure that it gets done correctly. Crawl space wall insulation, okay? So where installed, crawl space wall insulation shall be secured to the wall and extend downward from the sill plate to not less than the top of the foundation wall. All right. So you've got that. You need to make sure that if you've got exposed earth, that you are covering that with a class 1 vapor retarder. Class 1 is a vapor barrier. Okay. Vapor barrier, class 1 vapor retarder. You got to make sure those joints are sealed, make sure that it's lapped up and fastened around the perimeter. So they have clear definitions of, if you do a crawl space, what you need to do to comply with code there. Radiant barrier, this is new. Prior to the 24 code, there wasn't anything about radiant barrier in the code, but in 24, they added it in several locations. So where did they add it? First of all, it's radiant barriers is in section 402.3. This is prescriptive path only. Where installed, radiant barrier needs to comply with ASTM 1743. There's also general definitions, or in the general definitions of the IECC 202, they've got a definition of what a radiant barrier is. Okay, material having low emittance surface of 0.1 or less, which of course is the definition of a radiant barrier, 0.1 or less. They also talk about, though, reflective insulation, okay, which is reflective insulation and what that means, because in the code, we're also talking about including that. They talk about airspace, where the R value of an enclosed reflective airspace. So this is another place where they're talking about radiant barrier. And then 30322, they talk about where installed. So these are the sections where radiant barrier was added into the code. I might have missed one, but I don't think I did. But the cool thing is that radiant barrier is now in there. So you're getting credit in the code for radiant barrier, where before 2024, there really was no place for you to get credit in the code for doing it. Except, of course, if you did it in the performance path, your energy model could give you credit, and that's an indirect way of getting it. But the code itself outside of the performance path, you're not going to be able to get credit for radiant barrier, whereas now you can. Fenestration, okay? This is prescriptive path only. The area weighted average of fenestration products shall be permitted. So if they call out a U factor or a solar heat gain coefficient, then you actually can do the weighted average of that. So let's just say that the solar heat gain coefficient is 0.35, and you go into a house and you see 0.34, perfect, 0.35, check, 0.32, check, 0.36. You got one window at 0.36. Well, that window doesn't necessarily fail because of 40241. As long as you've got plenty that are of windows that are below, then the area weighted average is going to be good. And when you're doing inspections in houses, if you're a building code official and you're doing your inspections, as long as you're seeing most of them at or below your target, I wouldn't sweat it. If it's close, you might have somebody run a calculation for you, although I'm not even sure that, unless you see something really whacked, I'm not sure that's going to be worth all the brain damage to do that. So there's the area weighted average of fenestration, 40242. They also do glazed fenestration an exemption. So you're allowed to have up to 15 square feet of window glazing that is not compliant with the code. So this takes care of the occasional butt jointed windows or things of that nature. So there's a little bit of an exemption there. And then for opaque doors, remember, fenestration is both windows and doors. Fenestration is both windows and doors. And so for opaque doors, there's also an exception. You get up to basically one standard size door, 24 square feet, does not need to meet the code. They give you only one of those, I call it get out of jail free cards. You get that in the opaque door 40244. Okay, so air sealing is in the code. It applies to prescriptive performance in ERI. Thermal and air barrier, air sealing, and insulation requirements are defined in table 402511. That's the thermal bypass checklist in the code. I'm going to come back to that one when we get to the end on testing and inspections. New wood burning fireplaces shall have tight fitting dampers and doors. The code requires insulation contact airtight ICAT light fixtures. Specific air tightness requirements for doors and windows. Now, this is a little bit of a catch, because here's NFRC stickers where you get your performance information on windows, right? There's the U factor, there's a solar heat gain number, which we've talked about. There's the visible light transmittance, then there's air leakage. But notice on this NFRC sticker, they put NA, okay? What about this one? Dash. On this one, they didn't even add it. There's not even a box for the air leakage. A lot of the time, in fact, most of the time, windows do not include this information. Now you could go back, because the code has a specific requirement there, you could go back to the contractor, the builder, and make them get you a label or that definition of what is the air leakage on this window. But I'm here to tell you that is a hill you don't want to die on. You don't have to die on. Rely on your blower door number, okay, your envelope leakage. If all the leakage was in your windows, that means they'd have to tighten everything else up. So just rely on your blower door number, okay, which is required. And don't kill yourself to get this information out of the contractor when it's not readily available. Just a tip on that. If you want to go all out, you can require the air leakage number for your windows. But I, again, tell you it's not really that necessary because you've got blower door. Electrical communication outlets boxes penetrating your air barrier. So if you've got an outlet box on your exterior wall, all right, you definitely need to make sure that it is compliant with air tightness. So it used to be in the 21 code that it was a little ambiguous, okay? Because it says electrical communication outlet box that penetrates the air barrier of the building thermal envelope, okay? So if your air barrier is the exterior or the inside, that's where we're talking about this applies. And then of course, the box needs to be labeled NEMA OS 4. This is the requirement that's in there. I question whether or not you would turn down a box that's got a gasket and air sealed. But again, that's your call as a building code official. If you saw somebody going this far on a box and it didn't say NEMA OS 4 on it, would you call them out on it? Would you fail them? I would recommend that you not. They've clearly demonstrated that they're working hard at it. But again, this is a requirement that is only for the prescriptive path in the code, meaning it doesn't show up in those tables for 405 and 406. Okay, what about the programmable thermostats? At least one per system. Duct system design. So in the code, it's been there for a while. In fact, this has been in the code, going back quite a way, that you've got to make sure that your duct system design is, actually this one's new, sorry. The mechanical sizing's been around, but the duct system sizing is new. 1 or 2 dwelling units, ANSI ACA Manual D for duct design. More than 2 dwelling units, you can follow the ASHRAE handbooks of fundamentals. So apologize, I got in front of myself a little bit. This is new. They didn't have duct design requirements until the 24 code. Building framing cavities shall not be used as a duct or a plenum. That's been around. Minimum duct insulation, okay, R8 for your ducts that are bigger than 3 inch, but if you've got your high velocity 3-inch ducts, then you can go down to an R6. To be considered inside conditioned space, the ductwork, they give 3 options: 100% within the continuous air barrier, ducts in a vented attic or unvented attic with vapor diffusion ports, ductwork within the wall or the floor assemblies. Each of these options, 40334, I actually cover in my ducts in conditioned space class. So if you want to dive deeper into this and the code requirements, that's actually a great class you might consider taking in order to learn about the details of what we're talking about in this particular one. Ducts, air handlers, and filter boxes shall be sealed, all right? Got to make sure that your ducts and filter boxes, they're all sealed. Air handler, unit, cabinet, leakage no more than 2% of the designed airflow. Here's another item where your air conditioning unit manufacturers, they're not readily providing the leakage of their cabinets. Can you get it? Yeah, but it's not readily available. And you're not going to be having the rater test the tightness of your unit to see if it's 2% of design or not. This is another one, like Windows, where I say, I wouldn't die on this hill, okay? Don't demand to know that that air handler is no more than 2% leakage, because quite frankly, rely on your duct leakage requirements. The duct leakage, as long as that thing hits the duct leakage requirements, you're good to go. So that's what I would do. And if the cabinet is too leaky, well, they're gonna have to have really tight ducts then. So this is one of those things also as a code official, there are bigger fish to fry than fighting over this when we know we've got a duct leakage test that's going to tell us how tight our duct system is, and make sure it hits that number and you're good to go. Duct leakage testing requirements, I'll cover that when we get to testing. Circulating hot water system installation criteria. So if you're going to put in a hot water recirculation system, there is a definition of how to do that. Some people confuse the fact that because the code talks about circulating hot water systems, that the code requires a circulating hot water system, but in fact it doesn't. The code does not require that you put a hot water recirculation system in. If you install one, you have to follow the code's criteria, but it's not required. And I'm gonna make that even more clear here in a minute. So they do have a requirement for prescriptive performance and ERI. This was in the 21 code, this was only prescriptive, but in the 24 code, they added in performance and ERI. And depending on what you've got for your piping, if it's 3/4 inch or larger, or fits any of this criteria, you're gonna need to put an R3 insulation on that, you're gonna need to insulate it. The minimum insulation is actually in a table and actually a formula. So it used to be R3, as I say, was R3, but now they've elaborated and there's a calculation to determine how thick your insulation needs to be instead of a one size fits all. Yes, it definitely got more complicated. Something that was simple now has been more complicated on your pipe insulation. Drain water heat recovery system. If you install one, they have installation criteria. Because this does not require you to install a drain water heat recovery system. And the only reason I said something that's kind of silly is because, again, I've talked to code officials that require hot water recirculation systems. And I'm trying to say, no, you don't, it's not required in the code. It's only required to follow the rules if you install one, because not all homes are required to do a drain water heat recovery system. Now, here's that mechanical requirement that I accidentally just misspoke on. So this is the design requirements for Manual J, Manual S that are in the code. You've got to refer, in this case, to the IRC. I told you there's a few places where you have to go and look elsewhere. This is one of them. So in here, you go and you look at the IRC 1505.4 for the requirements for the ASHRAE ventilation. Now, what they did in the 24 code is what I suspected they would do, is they added in an HRV, ERV requirement for climate zone 6. I wasn't sure if they were gonna add 6 and 5, but they added 6. So in the 21 code, you had to do an ERV or an HRV if you were in climate zone 7 or 8, and I love it. It's the best ventilation strategy is an ERV or an HRV. And if it's really cold outside and you got to spend a lot of time indoors when it's snowy and cold and wintry, then you're going to need to make sure you have the best ventilation. So the code in 21 required that it be in climate zone 7 and 8. 24 code, they backed it up to climate zone 6. Lastly, the system shall be tested and verified to provide minimum airflows. And then we'll come back to this one again in the testing and inspections. Intermittent exhaust controls for bathrooms and toilets. This is new, okay? This is new. Where an exhaust system serving a bathroom or toilet room is designed for intermittent operation, the exhaust system controls shall be one of the following. So now what they're doing in the 24 code is they're saying that you've got to put controls on your intermittent exhaust, either a timer, occupancy sensor, humidity control, contaminant control, any one of these you need to include on your bath fans. Here's the sizing, okay? So for HVAC equipment sizing, you need to follow Manual S and Manual J. This has been in the code, this is what I was saying before, this has been in the code since 2006. Equipment efficiencies must meet the federal minimum standards, 403.7. Electric resistant space heating, this is new. This is basically applies to 1 and 2 family dwelling units, climate zones 4 and 8. So your colder climate zones. If you're doing electric resistant space heating, they've got specific requirements, okay, that you need to do. Space heating capacity limited to no more than 2 kW. Largest spaces that is not used as a bedroom shall install a heat pump. So this is trying to get rid of the bigger energy consumption, which is electric resistance in buildings. So they do have this new requirement 40371 that is added in for the 2024. Requirements for mechanical systems located outside. This is a new requirement in the 24. So if you're heating outside a building, snow melt systems, roof and gutter de-icing controls, freeze protection system controls, any one of these is going to require that you follow a certain requirements that are outlined in the code. And again, I'm not going to spend time walking through each one of these requirements for the code. If you have any one of these things, then go into the code and see exactly specifically what it requires. Now, snow melt and ice systems are in the ERI and the performance path as well. But I want to reiterate that just because snow melt and ice system controls are in the code doesn't mean that you've got to install in every house a snow melt and ice system. And I know that's facetious because we're not going to have that in Phoenix, but I'm going back to illustrate the point that a hot water recirculation system, just because it's mentioned in the code, does not mean that it is in the code. Now, municipalities can adopt it into the code. Keep that in mind. They can adopt it into the code. Okay, timers and pool pump heaters requirements, covers on heated pools and in-ground spas if they're heated. Gas fireplace systems shall not be equipped with a continuous pilot light, okay? So they put that requirement in there. Gas fireplace efficiencies, that's new, adding that in there. Electric power lighting and renewable energy systems. So lighting requirements and power requirements for all permanent light fixtures. So now what they've done is they've added in a lumen, not less than 45 lumens per watt, not less than 65 lumens in your lamps. So what they've done is they've beefed up, it used to just be 100% was efficient. Now they've actually clarified that in terms of lumens, which is more accurate, and you're gonna get more of what you're looking for there. And so for lighting, powering all appliances, or for building exterior, you can see this is what we're looking at for the requirements for the different products. Interior lighting controls, you can see they added in habitable spaces versus garage and unfinished basements, what needs to be done there. So there's more requirements there. Exterior lighting controls, prescriptive path only. They talk about what's required there. This is if you've got 30 watts or more on your outside of your building, 30 watts or more. So if you've got, couple of light bulbs that are LED that are, less than 30 watts, you're only going to get about 2 bulbs to do that. Any more than 2 bulbs, and you're going to need to put in exterior lighting controls, okay? Again, prescriptive only on that one. Okay, I know I went lightning fast and you guys are like, whoo, but I wanted to get through what is in the code, just so you know what's there. You guys will get a copy of my presentation and you can go back and look at the details of the highlights. But you're gonna need to spend time looking at those individual requirements if they apply to you or you're trying to do one of those things. Now, when it comes to appendices, we had 3 appendices as of the 21 code and before that, but up through 21, we had a Board of Appeals, we had a solar ready provision, and we had net zero energy. That was in the 21 code. And I wanted to clarify that the appendices are not mandatory. If something is in an appendix, it does not apply to the buildings, not unless your municipality adopts an appendix into the code. This is important to know. So if you're in a municipality and they start citing stuff in the appendix, then you need to say, wait a second, was that adopted into the code? Because if it's not adopted into the code, I don't got to do it. And that's true. So only appendices that have been adopted into the code by a municipality, when they adopt a code, do you need to worry about them. Okay, so we had 3 and they added a bunch more in the 2024 code. Now, notice that I put down here highlighting a few of these in blue. The ones in blue are the ones that were subject to the appeals process. So there were some things that were in the code through the end of 2023 that were going to be adopted as permanent items in the code. And what they did in the appeals process is they didn't actually throw out some of these things. They just moved them from mandatory in the code to an appendix, non-mandatory. So some of these things that are in the appendice, we may see in the future. They may move them from an appendix into the code in the future. But for now, they've got a home in the non-mandatory part of the code, which is the appendice. So keep that in mind. And again, we could spend an entire day going through each of these appendices so you guys could understand what's in them. We clearly don't have time to do that today. So I'm not going to do that. I will leave it to you to go through the appendices and look at them one by one for the contents for those. I will stop for a second and comment that one of the things that the code has now done is they've made the need for a professional to help you as a builder or a designer you need a professional that understands all of this stuff, because now it's just getting more and more complicated. A little like the tax code, right? When the tax code was one page, you could do it yourself. But as we continue to beef up and get into more and more details, now you've got to have outside help to make sure you comply with everything and you don't miss anything. And also that you make sure that you're not doing anything more than you need to, which comes to our options for complying with the code. So I have defined, as I go through the code, there's about 9 ways that you can comply with the code. Not all of them apply in all locations and in all jurisdictions, but I just wanted you to be aware that there's a lot of ways to comply with the code. And what's important for knowing these options is that if you know the options, you can always pick the one that's going to be the path of least resistance, which is the easiest one to go through. And most people tend to default to prescriptive when they think of the code, because the code in the prescriptive defines specifically what kind of how much insulation you need, R value this, and U value that, very specific. But in reality, there's greater flexibility if you do some of the other options. So let's look through these. So option 1 is your R value alternative. Okay, this is where basically they define what climate zone you're in. Then you look down the left-hand side and it tells you what to do. Remember, this table used to be inverted, where the climate zones were down the left side and then what to do is across the top, but they wanted to make the list, these things, taller. So it makes sense. We just have to get our head turned around so that we remember how to read these tables. But what you do is you effectively follow the, whoops, sorry about that. You basically follow what it says to do. If you're in climate zone 2, this is all the stuff that you need to do for your U values, for your SHGC, your solar heat gain on your windows. Your attic's ceiling is R38, which I just highlighted. Remember, this was 49, 49, and 60. So this is one of those areas they backed off on. I wanted to, again, highlight that for everybody. This was one of those things they changed, but you got to know what climate zone you're in. And then you just go to this table and it's pretty simple. You do what it says. Prescriptive, though, in order to be a one size fits all, because you're not being very specific to that home or as specific, these are going to be high numbers. You're going to be doing a lot of extra material in the prescriptive path, because they've got to make sure, the ICC and the municipalities, that if you do prescriptive, you got to make sure that home is a good one. And so they've got very elevated requirements, but there's way to fine tune things. And here's that chart I wanted to show you guys about law of diminishing returns. I thought I had it earlier, but it's here. And so you can see that your biggest bang for your buck is actually your first little bit of insulation. But as you move out towards the tail, you can see that we're getting law of diminishing returns. And so this is one of the reasons why I'm pretty confident they backed off and went back to that, because you're really not getting anything from R49 to R60. You're just not getting much, and certainly not in Phoenix. In climate zone 2, you're not getting much. So I like what they did backing off on that. Now, remember, I already talked about the slab edge insulation, right? So what's new is they're adding in a heated requirement for climate zone 0, 1, and 2. If you do a heated slab, you're going to have to do a slab edge insulation, which is new. You need to, if you're following prescriptive, meet all of the requirements in the table, meet all the requirements in 402 to 404, the stuff we just reviewed. You meet all those requirements, and then you've got to go get 10 credits out of the additional energy efficiency packages out of 2 of the categories. If you're 5,000 square feet or bigger, then you're going to need to get an additional 5 points, if you recall from what I shared with you. This is how you do one path, one option for complying with the code. The next option is the maximum assembly U factor, okay? And so in this case, what we're doing is we're basically, depending on what climate zone you're in, you've got to hit these U factors. So now it is the assemblies that we're looking at. So for example, let's take a ceiling. We're not just talking about putting an R30 bat or an R49 bat in there, or blown in insulation. We're actually talking about the U factor for the assembly. So if we translate 0.026 into an R value, which is the reciprocal, you can see that we get about an R38. Remember that it's normally R49, but what we're now saying is that you don't need to be R49 for your assembly, because we're talking about some wood in the path, we've got some drywall. So it's a system. And so that's where the U factor comes in. And you're basically allowed to insulate at about R38 if that whole thing works out. Now, how are you getting the U factor for your assembly figured out? That's basically computer software is doing that, okay? That's not something typically being done by hand calculation. Notice that they've also thrown in here the F factor. Remember I said that F factor was going to be thrown in? Okay, this is that thermal conductance, okay? Thermal transmittance, excuse me, thermal transmittance. This is new. I said thermal conductance before. This is a new factor that they threw in, thermal transmittance. So meet the requirements in the table, do everything in section 402 to 404 that we highlighted, everything, and then you got to go get 10 points out of the packages, and you meet the code. Option 3 is the component performance alternative, okay? In this case, what we're doing is we're basically going to go back to the table that we just looked at, 40212. We're gonna grab the U factors out of that table, and you can see here are the factors. You take the U factor from the table we just looked at times the area of that ceiling or wall or window or floor, and you calculate those two numbers, and it's going to give you basically a unitless number. Then what you do is you say, what am I doing in the house I'm building? So let's just say we want to do a little worse. Lower is better on U factor. So we want a little worse in our ceiling. We don't want to do quite as good. Fine. And in our window, we don't want to be quite as good. So we're going to do a little worse on our thermal conductance for our windows. And then if we do that, though, we're going to have to do better elsewhere to make up for it. So there's some trade-offs in the shell that are allowed in your option 3, which is the component performance alternative. So now we can do 0.30 or 0.40 to make up for the fact that we did a little worse in other areas. Now they put a limit on your windows and doors for what your U factor can be. So climate zones 4, 5, 6, and 8, they do say that you can only go so high on those, and they limit it to no more than 0.48 or 0.40 in the colder climates. So you basically meet all the requirements in section 402 to 404, plus you do this little math comparison, get 10 credits and you're good to go. This is absolutely done with software, right? And so your Radar software will run this calculation for you, okay? And as long as the IECC reference is greater than your as designed, so you are good to go. It'll meet the requirements of the code. So that's your third way. And by the way, all 3 of these methods I just shared with you are part of the prescriptive. So prescriptive is not just one, it's 3 subpaths within the prescriptive. Then there's performance, okay? This is our 405, simulated energy performance, where you're basically putting all of the characteristics of the home into the software. The software will then kick out a performance for you. How are you doing? They have the same limits. So you can only go so bad on your U factors in climate zones 4, 5, 6, and 8. They've added in that your solar heat gain coefficient in the hottest climates cannot be any worse than 0.40. So they've put a few backstops in here when you're doing performance path. The thing about the performance path is that unlike the prescriptive path, we actually can trade off and get credit for heating, cooling, and water heating. So now it's not just the shell performance, it's also the performance of your heating, cooling, and water heating. This gives us much greater flexibility in our trade-offs. So if you do a poorer other area of your building envelope, well, you can make up for it in doing a really efficient air conditioning unit, for example, okay? The maximum allowable total building thermal envelope conductance is now allowed to be this. So in climate zone 0 through 2, what they're doing is they're saying you can be 8% more effectively in your thermal conductance from whatever the reference is. So they're going to allow you to be only 8% worse. And if you're in 3 through 8, you can go up to 1.15, or 115% in your thermal conductance. So they're allowing you to be go no more than that in your 405 performance calculation. Annual energy cost of dwelling units versus the annual energy cost of your reference. We're comparing the energy costs in this one. So you've got your reference design energy cost and the home you're building, and you compare the two. So this is how they're doing additional energy efficiency. Instead of following one of the packages in the 24 code, they did away with that, and they basically said you're going to have to be at 80% of your reference building. Okay, so dwelling units with one or more fuel burning appliances, you're going to need to be at 80%. So if you've got gas appliances, they're going to require you to be 20% better than the reference. So you don't get to just hit the reference. You've got to hit the reference, and then you got to be either 20%, or if you're all electric, you can be 85%, 15% better. So they're giving you some parameters. In the 21 code, basically what the 21 code was saying was meet the code and be 5% better. That's what they did with the additional energy efficiency in the 21 code, what they're doing. In the 24 code, they pushed the envelope, okay? 20% better and 15% better. Now, if you're larger, add an additional 5%. So you could be as much as 25% better, required to be 25% better than the reference home. So that's how they're juicing the code to get onto that glide path to net zero. Maybe even overshooting it a little bit, according to my chart, but maybe not. And so you can see that if you do performance path, it just got harder. Not just 5% better, it's going to be 15 to 25% better, depending on the size of your building. This is how they do additional energy efficiency in 2024. In the option number 4, you also need to go and do the things that are listed in the table 405.2. I call it the cherry picking table. So you got to go into that table and do whatever it says out of 402 to 404, and you meet the code. Okay. Here's the calculation, by the way, that comes out of the software, the rating software anyway. As long as your dollars and cents are lower, you meet the requirements. Okay, for the ERI, they've listed basically, depending on if you are including on-site power production or not including on-site power production. Okay, so what they've basically done is they've indicated what the target is depending on what climate zone you're in. It tells you where you need to be. Okay, so if you don't include on-site power production, you're going to be hitting these scores. If you are otherwise, your energy rating index with solar needs to be here. Now, in the 21 code, they basically said if you have any solar, you got to go to 0. Okay, so I like that they backed off of that. In the 24 code, they're now saying that you've got to go to a lower HERS index, not HERS index, ERI. HERS index is an ERI, but you got to go to the ERI. You got to go to that number, but it's not 0, and that's what it was basically in the 21 code. So I like this better. Now, what else you got to do? This includes heating, cooling, and service, hot water heating. So it's going to include all that because that's what an ERI does. They put the same parameters on for thermal conductance. Okay, you've got to have limits on this, climate zone 0 through 3, and you meet all the requirements in 402 to 404 that are in the 405.2 table. Okay, now above code programs. This has been in the code for a long time. They did change the number, but it's 10411, and the local municipality can deem a state, national, or local energy efficiency program to be above code. And typically it's going to be the Energy Star program. So they can say, if you're Energy Star, you meet the requirements of the IECC. Done. So they can do that. That's certainly something that your municipality can do. But not all programs are Energy Star. So one of the things they did is they put some backstops in. If you're not Energy Star, which does meet these requirements, they said that your building needs to meet certain minimum requirements for the basically the cherry picking table for R405. That's table 405.2. So they're going to say that you've got to make sure you meet those minimum prescriptive requirements. And you also need to make sure your thermal envelope at least meets the minimums, climate zone 0 through 3 for thermal conductance. So not just any program can qualify, there's some minimums there. Local amendment. Okay, City of Phoenix actually adopted the HERS index, not ERI. This is before the ERI was in the code. They basically said if you were a 73 or lower, you met the code. Then they lowered it to 64, and I think they're probably still at 64. This is a whole nother option for compliance, an example of one that your local municipality can adopt. So this is a local amendment that can also be a path for compliance, which the city of Phoenix did, and a lot of the municipalities within the Phoenix metro area followed the city of Phoenix on that. There's one more path option, which is 8. This is for log homes. So if you're building with log homes and you go to the IECC general provisions R402.1, what they do is they have some exceptions in there. The exceptions in there include log homes. You can comply with the IECC 400 and it will take care of all of those sections I just crossed out in the bottom. So if you follow IECC 400 for log homes, you don't need to follow the main code when it comes to this. You go look at the IECC 400 and it gives you your requirements for your thermal envelope. It gives you requirements for your infiltration, and it only applies to the log portion of your building if it's a mix of structure. And then lastly, we have the tropical climate regions, okay? So if you are in 2,400 foot sea level or below, then you can always look at the tropical climate region. No more than 1/2 of your occupied space can be air conditioned. If there's more than half, you can't follow option 9 or 407. The occupied space cannot have any heating. If it has heating, you can't follow 407. Solar, wind, or other renewable energy source, not less than 80% of the energy service providing energy for your water, so on and so forth. I'm not going to go through all the details on this. You do not need to comply with sections 402 to 404, anything in the prescriptive, except permanently installed lighting needs to meet the section 404 requirements. That's one area that you do need to follow. Okay. I went through that pretty quick, right? We're trying to pack a lot in here, and I still got one more thing to cover with you guys. So those are the options. There's a lot. I will tell you, most of the builders are doing 405, the energy simulation, right? So this is the one because it creates the greatest flexibility. It includes the most stuff, and it also excludes a number of prescriptive requirements. So most of the builders are doing the simulated building performance R405, and then you can decide for yourself how hard the other ones are, but I think you might have a sense of that after at least getting an overview that I've provided. So let's look real quickly at the testing and inspection requirements, because if you're building to the code, you're gonna have to have somebody helping you out with testing and inspections, third party, okay? So they've added a number of things into the 24 code when it comes to testing and inspections. For example, sampling. They've added in sampling, but what they did more specifically is they excluded it from single family homes, okay, and townhomes. So we were doing sampling when it came to the code and code compliance for many, many years, and we still are because the 2024 code has not been adopted. And I don't know if municipalities will say it's still okay or not, but nonetheless, the code explicitly says you cannot do sampling for single family or townhomes. However, it is allowed in your 8 or more dwelling unit buildings. So if you've got a building with 8 or more units, they will allow you to do what we basically know as our standard sampling process, which is 20% of your dwelling units, okay? What is allowed to be sampled? Envelope leakage, duct leakage, ventilation system testing. That's what you can do sampling on, according to the 2024 IECC. They also add in there who's allowed to do the testing inspections. It was silent on that. But they've given some helpful advice on this. Approved third-party inspection agencies have been defined, okay? You need to have approval prior to the issuance of your permit. So technically, the municipality will not issue a permit until you've said who's your third-party inspection agency, and they need to prove them. They're either on a list or you've proven that they know what they're doing. In fact, here's your authorization, okay? So 107.4.1 says, what are the requirements? Who's authorized to be independent? First of all, demonstrated independence. Equipment, adequate equipment for the performance. They've got to demonstrate they've got that. The personnel should be credentialed, trained. There needs to be documentation that they're a rater or BPI certified or National Balance Institute certified. Whatever the requirements are, they need to be able to, prove that they meet those requirements. An approved third-party inspection agency, there's a definition of what is reporting. What do you got to do for the reporting? So they've really beefed up the testing and inspection stuff inside the 2024 code, which I think is kind of handy because it's been, I think, a mixed bag across the country as to what do we need to do? What are the requirements? Who can do this? What credentials do they need? The 24 code has added that in, and I think that's a good thing. Now, the code up to today, up through the 24, has defined that thermal and air barrier inspections are by a third party or can be by a third party, envelope leakage testing by a third party, duct leakage testing has not, and still doesn't define a third party. I wish they just took the same language out of envelope leakage and stuck it into the 24. And of course, I'm guilty for not making a public comment on that and a recommendation during the code hearings. Slap my wrist for not doing that. I was hoping somebody might wake up and do that. It's not a big ask, but they need to say explicitly for duct leakage, third parties allowed, like the language you see there. For ventilation, they did it. They went and grabbed the same language and said third parties acceptable. And then lastly, for the energy rating index, you need to have somebody that's going to verify all those ERI components. This was added in the 21 code. It continues forward. Pretty much this language right here was in the 21 code. It just carries forward to the 24. So this was all there already. Now, visual inspection of your air barrier. What they've defined now, and actually it's been defined in table 40251. It's now not table 402.411, it's 511 in the 24 code. And so you can see that there is a thermal bypass checklist there. What do you got to do for your air barrier? What do you got to do for your insulation to make sure they're done right? And this has been in the code book basically since the 09. Okay, now it wasn't like this. It didn't look quite as organized as this until about 2015, if I remember right. But 2009, they actually had a thermal bypass checklist. And notice that if you're log homes, they put the exception in here, right? So for log homes, you do not need to follow this. They've got their own set of requirements in the IECC 400. Framing and air barrier rough-in inspections. This is new. So now they're actually talking about what do you do for a framing and air barrier rough inspection? Okay, air barrier inspections at framing rough-in shall be made before the application of permeable insulation and shall be used to verify compliance with this code. So they put in clarification of what does an inspection for framing and air barrier look like, and when does it happen? Rough-in inspection. Insulation and fenestration rough-in inspection. So they're defining that. Inspections at insulation and fenestration rough-in shall be made before the application of interior finishes and shall be used to verify compliance. So there you go. Now they've got definitions of insulation inspections. Okay, this was not in the code prior to 2024. This is new stuff. Envelope leakage. Okay, this is new, not envelope leakage testing, but what they did is they added in a little bit more granularity. It used to be 3 and 5 air changes per hour up until 21. Now what they've done is they've actually changed it so it's climate zones 1, 2, 3, 5, and they added in a new one, 6, 8, okay? And they've said 4, 3, and 3, 2.5. So this is a little more granularity, wanting to make sure that our homes that are in our colder climates are a little bit tighter, okay? A little bit tighter. So that is new for the 2024 code. Now for envelope leakage, what they've done is they've got a performance path that they did have, that even if you're prescriptive, you can follow the performance option in the code. This goes back to the 21 actually. And so the maximum allowable used to be 5 air changes per hour for performance, but now it's been dropped down to 4. So in all climate zones, or in the warmer climate zones, we're going to have to get our buildings a little bit tighter. We were at 5 forever. I say we because I'm in climate zone 2 in Phoenix, but now they've decided, hey, we need to juice that lemon just a little bit more, and now it's down at 4. They also said that you could do your percentage of your envelope. So 0.22 cubic feet per minute per square footage of your building thermal envelope. So they allowed there to be a percentage of your envelope, 22% of the area of your shell. There is an exception. You can take 0.22 and you can go to 0.27, a little bit worse if you're talking about multifamily buildings. And keep in mind, multifamily buildings have a lot of common shared walls, floors, ceilings. And so the only place that is infiltration to the outdoors is that exterior wall. Well, that could be 1 out of 6 sides, right? 1 out of 6 surfaces could be to the outside. And so they're allowing you to have a little bit of an elevated target. So you don't have to be quite as tight if you're multifamily or buildings, dwelling units, 1,500 square feet or smaller. So they put this in the 21 code, this a little bit of an exception allowance. Yeah, at least it's recognizing the difference between multifamily and single family when it comes to that. For duct leakage testing, okay, duct leakage testing shall be done. Okay, you must do duct leakage testing. And your duct system leakage allowables, they've moved it into, instead of just 4% or 6% or 8%, what they've done is they put it into a table depending on your conditions. So I'm not even going to dive into this in detail. Your rater will help you sort this out, but this is now the new requirements for duct leakage. You got to go into a table, and depending on how many duct returns you have, you know, your square footage, whether it's a small or a large building, defines what that leakage is. And then ventilation also needs to be inspected. Your ventilation needs to also be inspected. All right, Mike, I hit our mark. We were hoping that I'd be there right at the half pass mark, and it looks like I hit it. We covered a lot today. We squeezed a lot. I know you guys probably have a lot of questions and a lot of more information you want on details, but we wanted you to have some background in history. We wanted you to know what's in the code, details for highlights at the very least. We wanted you to be aware of the options. There's not just 1 or 2 options for getting through the code. There's a lot of ways to comply with the code. Now you know up to at least 9 of those ways. And critically important is also to understand testing and inspections, which really have been taken up a level in the 24 code in terms of definitions and what is required, who can do it, their requirements, as you saw in there. So we've shared a lot of information with you guys today. I want to remind you, I've shared this with you throughout class, but I do have a number of other classes that I teach. You can go to my website. We have master certification if you complete all 6 of my classes. And then also I have a number of other classes that I've mentioned throughout today. If you go to my website, you can see those on Energy Star, on water efficiency. This class, of course, I talked about my ventilation class, my shared solutions with virtual power plant, my newest class. These are all available if you're interested in learning more from Learning Edge. Would love to include you in any of those classes going forward. Okay. One more thing. I do a Q&A once a month for anybody that wants 60 minutes of my time, free consulting, paid for by my utility company sponsors. They're great at that. So if you have any questions related to building science or anything like that, you can join me totally free at my Learning Edge Live. I do it once a month. Next one's going to be in February. All right. So Mike's going to take some questions, but everybody, if you'd like copies of the slides, what I'd like you to do is to hit that QR code with your phone. And Mary, you're going to drop that, I think, into the chat. There it is. So you guys can click the link in the chat if you prefer, but you can also do it with your phone. That's going to take you to my feedback survey. 3 simple questions. You got to give me a score, 1 through 10. How did I do today? But then if you have time, give me some feedback. What'd you like about today? And then maybe what can I do different, like talk slower, have more time. I get that. Whatever you want to share with me, what can I do better? When you're all done with the feedback survey at the link, you're going to get 1 more email to download all the slides that I shared with you today. Okay, Mike, now I'm actually finished, I suppose, with that. And if there's any questions, I'm happy to take those.
All right. Well, we're going to let Darren get a drink of water while we let people know that they can send in their questions via the questions box. I will ask on your behalf. We have many, many questions that have come in already, Darren. So buckle up because here we go. We got a question from Clement, and this was early in the presentation. What is the lowest CFM of leakage that you've ever seen in a house or a residential unit? Have you seen anything less than 0.24?
So the only time I see anything down at 0.24 is if aero barrier is being used, okay, where they're doing aero barrier and really sealing that up for most of the houses to get down that tight. Now, that's what I've seen, but I haven't seen everything, that's for sure. But if you're going to be down at 1 air change per hour or sub 1, man, you're doing really, really well. And so if you're telling me that 0.24 is something that you've seen, I've never seen anything that tight before. But of course, I've never tried to push anybody that far to get that tight. And honestly, Mike, it's one of those other areas of law of diminishing returns. You know, you're going to get your air tightness down to a certain place where going tighter, you're not getting really any energy benefit. You can thump your chest and go, man, I killed it on this one. But I don't know that there's really going to be a huge energy benefit once you get down below that 1 air change per hour. I mean, there is some benefit, but it's, again, law of diminishing returns when we get down that tight. But congratulations for anybody that gets down sub 1. Like I said, I've only seen that in examples of houses that have got aero barrier used on it to seal everything up. So anyway, that's my response there, Mike.
Well, and it gets to a little bit to Ashley's question, because she was wanting to know, when you were using the phrase more bang for your buck when it regards to ceiling insulation at R60, do you mean then that it just simply plateaus as far as cost savings?
Yeah, or not necessarily, certainly a cost savings, but I showed that graph, Mike, where you get your first R2 to R10 is an 80% savings on your reduction in your thermal heat flow. Okay, it's just straight math, the heat flow equation. U, A, delta T, right? U factor times the area times the temperature difference across that area gives you your BTUs. And so it's just math, right? It's not me, being very subjective about it. It's just math. And if you plot that chart, you can see that when you move from R30 to R49, R38, R30 to 38, or R49 to R60, you're plateaued. You're not getting much. You're going to spend a lot of money, or not a lot. You're going to spend more money to get from R38 to R49 and R49 to 60, and you are spending money for that, but you're not getting the payback, which is why I believe, I can't say I've talked to anybody specifically about why the ICC, to their credit, backed off and said, look, R60 doesn't make any sense in Phoenix, or R49 anyway, it doesn't make any sense. So they backed us off to R39, and from R60 to R49, it just makes more sense from a bang for your buck. That's what I mean, bang for the buck dollars and also performance, Mike.
Okay, that's fine. That's fine. Just wanted to clear that up for Ashley. John had a question about the attic hatch. Is the foam closure of the attic hatch subject to any kind of long-term thermal drift number instead of the initial R, the sales R value there?
Well, thermal drift on foam is actually fairly stable. So you're not going to see a lot of that. And again, on that question, Mike, is he talking about the foam on the lid or the gasket on the attic hatch? Can you decipher from that?
I believe he's just talking about the hatch itself.
Okay, the foam that's on the hatch. And so again, if you're doing the foam, either you can stack up the expanded polystyrene that's the white foam, but you're going to put a lot of that on there, or you can do a high density foam like urethane. You're going to end up doing a much higher density, but you're going to get a much better insulating value there. And so, yeah, getting foam on that lid is better. I'm not sure that I'm answering his question very effectively. Over time, when we talk about thermal drift, usually that's degradation of the performance of insulation over time. Foam is pretty stable. So if you're putting foam on there, I can only speak to that. It's going to stay fairly stable over time when we talk about thermal drift.
Man, so many questions. We want to get to them all, and we are going to get to them all, but just preparing you, Darren.
Okay, I'm here as long as you need me to be.
Okay, cool. I had a question from Connor. Wanted to know that, this is kind of a general question for the whole code, really. With the modifications of the additional efficiency packages being tied to the prescriptive path, do you think it seems like the IECC is trying to push builders towards the performance paths at all?
That could be. I'll tell you what, they're spending a lot of time in the ICC code hearings to develop all these packages. And yeah, I guess they make them a little scary, Mike, because there's so much of it there. There's so much content, so much detail. I do not think that they're trying to push people towards the performance path. I think it inevitably is and does. From my experience as a home energy rater for almost 20 years, We never did prescriptive. We were always doing performance because we had the greatest flexibility when we did that. And so I do not think it's intentional. I do believe that what they're trying to do is recognize that not every builder wants to go hire a rater to do a R405 simulated energy performance. And so the simplest way to comply with the code is to do the prescriptive path in terms of simplicity of following the rules. It's not the easiest because, as I said, one size fits all is prescriptive. So they're going to put in R49 in the attic, even though your particular home could probably be fine with an R38. But they're going to make sure that if you do the prescriptive list and you do everything in there, ICC wants to make sure that that home meets a certain minimum requirement, regardless of its configuration. They are putting some granularity in there for larger homes, as you saw. That was added in there. But generally speaking, they're not saying that the 2-story versus 1-story. They're not talking about certain volumes other than that 5,000 square foot parameter that's been added in there. They're really saying one size fits all, and so they're going to overdo it. So prescriptive is always going to ask for way more than you really should do, because if you compared prescriptive to performance, and in fact, let me give you an example. The ERI path is now at, when it first came out, the ERI path for climate zone 2, I believe it was a 52, okay? So in Phoenix, you needed to be a 52 if you were doing the ERI path. If I took that same exact house, if I took a house and I put it into the rating software and calculated an R405 compliance, I would get that house to meet the R405, which is one of the options, right? You can do 405, you can do prescriptive. But if I got that house to just meet the R405 requirements, and I kept making the insulation a little better, a little better, a little better until I hit it, or maybe a little worse, but right at the threshold of R405 compliance. And then what I did in the software, because I said, okay, I've just met the R405. What's the HERS score for that? What's the ERI for that? And it would be like a 73 or a 72 in Phoenix, okay? So why would I do the ERI and go all the way down to a HERS index of 52 if I could comply with basically a HERS index of 72, which is what the R405 equivalent was? And so prescriptive is kind of the same thing. You can do all the stuff prescriptive says, but it's going to make that home's going to be way better than it needs to be to just meet the code. And most people just want to meet the code. They're not striving to be the lowest HERS score out there unless there's something tied to that incentive, or you're trying to compare to another builder and say we're better. That's obviously the advantage of an ERI. But if you're just trying to comply with the code, tell me the least painful way to get that done, the easiest way to get it done. And that's why the performance path is typically that.
Okay. Let's switch it up a little bit. Let's talk about skylights. Kim wanted to know if there's a requirement for skylight well walls to be insulated and sealed to match exterior walls.
So that's a really good question. The location of your air barrier is what matters. Now we're talking pure building science here. If your skylight lens at the ceiling line, if that is your air barrier, then technically those walls don't need to be insulated for the tunnel, okay? On the other hand, if that's just a piece of plexiglass and it really is not an air barrier, then you're going to need to make sure that well is insulated, okay? So it's a definition of where your air barrier is. Now, keep in mind that the code does say what your minimum U factor of your skylight is, and your U factor and not solar heat gain, but I guess solar heat gain would apply a little bit there. But certainly your U factor if you're in the prescriptive code, it's going to define it. So I will just tell you right now that whenever I've been doing the thermal and air barrier inspections, I've always assumed that the walls of that skylight need to be insulated with thermal and air barrier alignment. Getting that done correctly is a bit of a trick. When you consider the framing detail, what the framing looks like on the walls of a skylight, you might have framing that's going across there that's flat framing between two trusses, and you can't get the insulation in between the triangles that the truss is creating without cutting that insulation and getting it that basically 2x4, the 2-inch, 1.5 inch dimension. You're going to get that in there. You know, that's where it's difficult to get the insulation aligned with the air barrier on a skylight. So skylights are really tricky to get insulated correctly. They're really tricky, but in almost all cases, we always treated the well of a skylight like our thermal envelope and our air barrier. It was usually all included. So Mike, it depends on the circumstances how you treat it, but most of the time we'll call that well inside conditioned space. With the skylight itself at the roof, that actually is complying with the the code requirements.
And then the follow-up, the additional question on that same topic is, what about roof curbs for flat roofs?
Oh, curbs. Okay, so now we're into details, right? And so and we call those usually parapet walls. So parapet walls on a flat roof, those are outside typically, and those are going to be outside. But the blocking that you do at the ceiling, the roof line, or the ceiling line, it depends. So if you're doing cathedralized unvented attic with the insulation at the underside of the roof deck, well, that roof deck is the plane of your air barrier, and it needs to be continuous all the way to the outside wall, so we get insulation all the way out to the outside wall. And that at the base of the parapet, there's usually blocking. Well, that blocking all needs to be air sealed so that you don't get any hot air in the summertime moving from the parapet down into your attic space. These are all those framing details that the rater, whoever's doing your thermal and air barrier inspections, is going to sort out for you, because you want to make sure that parapet is isolated. It is outside the space. I guess you could try and make it inside the space depending on its characteristics, but almost always that's going to be outside your space. So the blocking at the base is what is critical, so you don't have the hot air coming from that down into your attic space. Now, again, if you're not doing an unvented attic and your ceiling line is where your insulation is located, well, then that connection from the parapet to that attic space is fine, because it's all outside conditioned space.
Okay. I want to get to a question that will elicit a little bit of a smile. Unfortunately, we didn't get to it before he had to depart, but friend of Green Builder Media Webinars, Mike Barsick, sent in a question. He wanted to know what an O'Hagan vent is. He wasn't sure what.
Yeah, I love it. An O'Hagan vent, I don't have a picture for you guys. You guys can look it up on the internet, but an O'Hagan vent is basically, it's a flat vent that fits on your roof deck. So when they're building your home or your roof, what they're doing is they're putting in these square vents that have louvers on them, and usually those are put on the roof deck, one high, and then usually directly below it there's a low one. So you get the air coming in through a vent that is going to be maybe 2, 3, 4 feet off the top plate where the roof connects to the top of the wall. Go up about 2, 3, or 4 feet. You put a flat grill there. It's like a square vent, and then you put one directly above it, usually high, and now you've got the air coming in and venting in the summertime for hot air, or in the wintertime it would be going the reverse, right? Depending on how you do it. O'Hagan vents are usually going to be, certainly we see them in hot climates, and then they have tile integration that goes over those or around them. But they integrate, they look like part of the tile roof in many cases, but that's what an O'Hagan vent is. I appreciate that question, and it's a good one.
All right. Let's move to something that you had mentioned when you were talking about R402.5.5. Ryan wanted to know if you know of any NEMA OS4 boxes for use with conduit.
For use with conduit, I don't know, so I can't answer that question. I have looked at, when I was kind of getting my hands around what a NEMA OS4 box looked like, I did some research on that, and I can't say that I saw in my research anything where you've got the conduit connected to those. So Can't be of help there, Mike. I haven't seen anything that I could share. I would be very surprised if there wasn't a NEMA OS4 box that Conduit can attach to. I'm sure there probably is, but I didn't dig deep enough to see that particular type of box.
Okay. Let's get to a question from Vanessa. She wanted to know, what do you think the most common options for ducts in conditioned space will be?
So probably one of the most popular ways to get your ducts in conditioned space, and again, in my class, I go through all the different details, Mike, and I talk about the pros and cons of each of them. I typically think in terms of production builders when I think of things getting done, because in custom, you can accomplish just about anything in a custom house because you're going to take the time to do it. But when we think about production builders, they're trying to figure out what's the easiest way to accomplish whatever it is our goal is. And if your goal is to get ducts in conditioned space, you can either move your ducts below ceiling line, and if you put them below the ceiling line, now we're taking away from ceiling height, and homeowners want higher ceilings, not lower ceilings. So that's one that we're not going to do. You could always do what I call a reverse soffit, where you build into the attic. Now you put your ducts up there and you insulate over the top of I call it a reverse soffit. That is very complicated to build that way. I mean, it's tricky. You can do it, but it's a tricky way to build. The code allows for buried ducts. Okay, a lot of work was done by the CARB group. That's a Building America partner. CARB did a lot of work in order to research just burying your ducts. And if you get your ducts buried in enough insulation properly, then they can be recognized as in conditioned space. And in fact, you can. The code outlines exactly what those requirements are, which again, I share in my class what those details are. Those details are actually in the IECC. It talks about what they are. But if you follow those guidelines, then you can just bury your ducts and you don't have to try and cathedralize or get your insulation up to the roof deck. Now, a lot of the builders are cathedralizing because it gets the insulation out of the way, gets it up against the roof deck. Now you've got a buffer space that is now your attic. It's not conditioned space. I call it semi-conditioned space. You're not insulating between the house and the attic. Now what you're doing is you're getting a space that might be in the research that was done by Building Science Corporation and work that I did, my own research, about plus or minus 5 degrees is the temperature of that attic space compared to the main house, which is way better than a really cold night or a really hot day in Phoenix, a really cold night in Minnesota. It's going to be a lot better, that space. So we're not necessarily directly conditioning it, but what we are doing is keeping it so that it has got some communication between your living space. So I would say that one of the, in fact, probably the most popular way to get ducts in conditioned space is just take your insulation and get it up to the roof deck. And we talk exactly about what the code requires. And by the way, those code requirements are in the IRC, okay? Those are all in the IRC, those code requirements. They're not in the IECC for ducts getting your cathedralized unvented attic. All that's in the IRC, not the IECC. So you're either burying your ducts, I would guess, or you're going to cathedralize your insulation are the more likely ways to get your ducts in conditioned space. I hope I've answered the question for Vanessa there. I hope I answered that.
It's all right. She'll probably let us know if you didn't, and we've got another question from her a little bit later on. Let's take another one from Connor. He wanted to know, are central fan integrated systems or air cycler systems, are they capable of meeting the CFM per watt requirements?
Depends on, well, that's a great question because now the CFM per watt is the air handler unit, right? Okay, so what is he talking about? This is basically fresh air duct to the return, okay? So if you take a fresh air duct and you go from the roof deck or an overhang or something and you drop that into the return, now what you're doing is using your air handler, effectively your air handler, to bring the air in when it runs its normal cycle. And so does it meet the CFM per watt? No, it doesn't. But now we need to start looking at just overall performance. Okay, does it? So for example, EPA allows for Energy Star. They require that you meet ASHRAE 62.2 requirements. Okay, that's what the ASHRAE, the code requirements are for, the requirements for the EPA Energy Star program. But what they require is that if you do an integrated central fan or the fresh air duct to the return, that the EPA since 2010 in Energy Star version 3, they've required that you put a motorized damper and a controller on there, so that we are effectively not running the air handler any more than necessary, and we're only getting the ventilation that you set for your programming for the controller for that ventilation fan. Okay, so you got to make sure that that stuff's all done correctly. Your rater, your air conditioning contractor, certainly your rater should understand how the programming for the controller needs to be done so that it's all working together. But I have not seen any homes denied for code compliance because they've done a fresh air duct to the return. I've never seen that done before. Technically, perhaps maybe they should be, Mike, is non-compliant when it comes to CFM per watt. But at the end of the day, it is a very, very prevalent way of providing ventilation for lots and lots of builders, and it's never been turned down. So I guess that's the best answer I can give you when it comes to that.
All right.
Probably insufficient answer, but there you go.
Let's go to one from Peter. You were talking about the law of diminishing returns. You mentioned it a couple times during your presentation. His comment, but really it's a question as well, is the law of diminishing returns, is it even worse when you're talking about SPF? Meaning if you move from R38 to R60 in fiberglass, it's not as extreme as R38 to R60 in SPF because SPF performs so much better.
True. I mean, it's foam is more expensive than fiberglass and cellulose, and so yeah, I guess in those respects, all you're doing is you're amplifying the problem. If you're using foam and you're trying to get to R49, well, first of all, when you run, there's a lot of ways to answer that question. Yes, it's more expensive to put more foam in than more fiberglass or more cellulose. Bottom line, yes. Okay, from a dollars and cents perspective. You do get better performance in many ways with foam, okay? Although you can install fiberglass and you can install cellulose in certain conditions and they can perform very, very well, okay? It's sometimes harder to get them installed correctly so that you get the performance that you're wanting, but it doesn't mean that they can't perform. You can install these products correctly and get good performance out of them. What I will tell you is if you look at the performance running an energy model, okay, like R405, and when I was running R405 compliance calculations or Energy Star calculations for homes in Phoenix doing cathedralized unvented attics, the R value of the foam at the roof deck complied with the code as long as you did good windows and your walls were good and your air conditioning unit was, decent. I was able to run energy models using, REMRate and Ecotrope software. I was able to run those energy models where we could get the insulation down to R19 at the roof deck, and it would still comply with the R405. Okay, and so we were able to hit that mark. And it was also because the insulation we knew was being done correctly as well. But the straight up energy model was showing us that we could get all the way down to R19. Now, we didn't do that. We typically didn't let the insulation at the roof deck go any lower than about R22. But we didn't need R30 at the roof deck. We definitely didn't need R30 in Phoenix to manage a really hot day here. We could easily comply with a well-built Energy Star home at R22 at the roof deck. We could hit our 405 requirements all day long, okay? So a little bit longer answer to that question, but straight up, it's gonna be more expensive to do more insulation than less, regardless of that law of diminishing returns when it comes to the performance of the insulation. And by the way, the law of diminishing returns, you guys can do this calculation yourself. It's basic, UA delta T. There's nothing special about that. R value does not say R value for foam versus R value for cellulose or fiberglass. It's R value, which of course is the reciprocal 1 over R to get you to U. So it's a straight, it's just physics, second law of thermodynamics, right? It's just physics is all we're talking about here. And so when we do that calculation, we're not defining whether it's foam or cellulose or fiberglass or anything else. It's just straight, what is the R value?
So talking about thermal values, R values, let's go back to the attic one more time.
Okay.
Vanessa wanted to know if the thermal tents over the drop-down attic stairs are still compliant.
No. In fact, actually, I said that too quickly. Vanessa, this was Vanessa's question. Okay, so in my longer class, this class is normally 2.5 hours, okay, without all the Q&A, okay? It's just, normally it's 2.5 hours. So, Mike, what I'll say to Vanessa's question is that in my regular class, when I do the attic hatch enclosure, that is a bear to get correct when you've got stairs, okay? The fold up stairs and you got a tent over it. There are tents that are fully insulated, I think, that can work. I show in my class a tent that a manufacturer, it's called Batic Door. Some of you guys might have known. I'm not trying to call out Batic Door on here, but I guess I am. Basically it's a cardboard box, and it's got a bat sitting in the top of it. So basically it's a cardboard box with a fiberglass bat sitting in the top part of it to give you R38, R49, R30, whatever, okay? And then it's got cardboard sides on it that fit down over the top of your stairs. Beautiful, okay? Your stairs are totally covered. The problem is that you've got cardboard for insulation on the sides, and it's about, 12 inches or 14 inches or 16 inches. And then the bat's sitting up here, basically just hovering over the top of your stairs, doing nothing, because your thermal bypass is happening through the walls of your Batic Door, which is basically corrugated cardboard, is all it is. And so I kind of do a little bit of a clarity on there from building science. I show that, I'm like, this is one way to comply with the attic coverage requirements, except it doesn't really work. You'd actually have to fully insulate all the way over on that tent. And I'm sure they probably make something like that out there that does have full insulation. So you're going from one side to the other, it's fully insulated, it's an air barrier, and you're truly insulating those stairs. That's what you need to be doing, not something that pretends to be insulating when in fact it's really not.
All right, let's get to a question from Robert. He wanted to know, how are renovations covered in the IECC?
Municipalities will define how much of a renovation they want to see your work in, okay? So renovations can apply to code, but the municipalities, they tend to be a little bit specific on what they want to see. So if you're doing a brand new addition on a house, almost always that portion is going to need to be code compliant. They're not going to make you take the rest of the house and bring it up to speed. Now, having said that, it doesn't mean that some municipalities might not say that. Some municipalities might say, look, you start touching your house, we're going to require that you put in, code compliance stuff. So the municipalities will define what that is, Mike. So I can't say what might be happening in Robert's particular locality where he's working, because that'll be dependent on what the local municipality is. So ask them; they will tell you where that line is drawn between you got to meet the code now versus you don't need to. Usually it's remodel additions or gut rehabs. They'll make you put that house back together code compliant. But other than that, they usually won't mess with your main house if you're doing stuff. But again, ask your municipality.
Okay. All right. So now we're to the portion of the Q&A where we're going to talk about inspections and testing, that portion of it. So let's start with this question here. Oh, by the way, Darren, we're going to go to the testing inspection questions, then we'll get to the hard ones. We're going to get you loosened up and then get to the hard ones.
Okay.
Connor had another question about compliance. do you have to use ResNet HERS raters for code compliance, or are there other organizations, and I think you listed a couple already, that certify individuals to perform ERIs, R405 compliance, etc.?
So as far as R405 is concerned, the calculations, R405 calculations, as long as it's an ERI approved, that's why it's not just ResNet. ResNet's HERS index is an ERI, but there are other organizations out there besides ResNet that can comply, other software that can comply with the ERI requirements. And so it does not need to be a ResNet for calculating ERI. Typically, the raters have the software that's all ready to go. It's a easy way to get it done because they're using the software. But if you're using Ecotrope software, you don't have to be a rater to use Ecotrope software or RemRate software or Energy Gauge. Those are the three that are out there. But Ecotrope is the biggest one doing most of the work. And so you could run that, but then the municipality, you've got to have confidence as a municipality that what you're getting in for calculations is being done by somebody that's qualified. That's where the 2024 code really stepped up its game, Mike, because you saw from my testing and inspections, the first part of it, I started showing you that any third party's got to demonstrate for the testing stuff, certainly anyway, they've got to demonstrate that they're accredited, either through BPI, which is another one, BPI or ResNet or National Balance Institute or some others out there. You've got to demonstrate that you have a credential that means that you're being oversawn by a larger organization. It's not just Jim or Jane with a pickup truck and a blower door, right? They're trying to take things to a place where they're not going to call out, you got to use a ResNet HERS rater. They're never going to do that. They're not going to say you've got to use a BPI person. They're not going to do that. They're just going to define what that inspector needs to have for skill set, equipment requirements, what the report needs to look like. And now we have that in the 24 code. And by the way, the 24 code's going to be worked in over the course of the next several years. So we're not going to see the benefits of 2024, these requirements, until for a while, because they're new for a new code that takes usually a year or 2 or 3 lag time. So those requirements, we're still on the 21 code or the 18 code, many municipalities. And so these requirements that I just shared with you today really don't apply yet, but they're great requirements for defining that. And if I were a municipality, and if you're in this class today and you're a municipality, man, what I would do, I would go and look at those 2024 requirements. There's nothing saying that you can't adopt those in if you wanted to. I got people right now probably wanting to shoot me for saying this, but you could grab those requirements. They've gone through the full vetting process, and you could just say, hey, let's follow these. This is what I'm going to follow. But again, municipalities can define what they want to do there. They can define that. Certainly if they want to be more stringent than what the 21 or the 18 or the 15 code says, you could do that. But it's written, it's gone through the full vetting process, it's sitting out there for adoption. And you could grab just the testing and inspection stuff and say, as a municipality, we're going to follow this. And I think that would be pretty reasonable to put those parameters in to know that you're getting testing and inspections done correctly.
Following along with this same general theme, so Ashley's got a ton of questions on testing inspections, but she said that she's going to just keep it to one for now. And you may see an email from some point with more questions. But she wanted to know, when it comes to those requirements, does this include, and it's a little bit of a long question, so stay with me, Darren. Does this include companies or firms that specialize in building leakage testing, insulation, duct testing? For example, a customer can hire a building envelope testing company to do a building leakage test for their project. And then there's a follow-up question to that, but let's stop there.
So in 2009, blower door testing was required, okay? In 2009, it was required. In 2012, I'm definitely dusting off the cobwebs a little here, Mike, but in 2012 is when they added duct leakage testing. And in 2012, here in Phoenix, one of the people that was very involved in code at the utility, one of the local utilities, they came to me and said, Darren, we added blower door last cycle. Now we're adding in duct leakage testing. And our municipalities, they have no idea who they can rely on for this. There's no rule set. All it says is third parties allowed, but that's it. That's wide open. Could it be, Billy Bob's air conditioning system, air conditioner that's now testing duct systems? Is that okay? So what I did is they came to me, and what we did is we actually created a model code that defined what testing was done, we actually defined that it was done by a HERS rater, because I was really only speaking to the HERS rater level. We always said that somebody else could, if they could meet the requirements, they could also be accepted. But basically we said, follow the ResNet standards for testing and inspections is what we did. Because at least it was a set of standards out there that defined how you do testing and inspections. You will, and I didn't say this because I was moving quickly today, but there are the ANSI 380 standards, ResNet ANSI ICC 380 standards that talks about leakage testing, okay? Ducts, envelope, and ventilation. So the code can, and actually I believe it does now, cites the ANSI 380 standard. So there's your testing requirements that are laid out in an ANSI International Code Standard, and people then follow those. So I didn't say it in my presentation. I probably should add that in there to be more clear that the ANSI 380 standard, ANSI ICC ResNet standard is one that you could follow. And now you've got a parameter that the minimum requirements are clearly defined in a vetted process by the international standards code adoption, or not code adoption, but standard adoption process. And so that's one way to define that. And again, Mike, I apologize. I really should know the answer off the top of my head, whether the 380 standard is cited. Now I'm actually going to jump off our call and go in there and look at it and make sure that I'm very clear on that in my presentation about that. So that's a standard that can be followed. Now, once you've defined the ANSI 380 standard, as your requirement for how you do a duct test, how you do an envelope test, how you do a ventilation test, once you've defined that, then, it could be Billy Bob's air conditioning system, air conditioners, as long as he's not testing his own work, because that's, part of the new requirements is you've got to have separation. And now you know what their definition is. The municipality has to decide whether or not they want them to go as far as being a HERS rater or a BPI certified contractor. So, the municipality will define that. They don't say that you have to be ResNet or BPI or anything. They just say meet these requirements.
And the good news is we have a report from one of our attendees that yes, 380 and
excellent. I thought so.
Well, and ASTM E779 are both cited in the interview.
Excellent, excellent. I thought so, but I just didn't want to speak too far out of school on that one. So I knew somebody would be on there to bail me out on that. So thank you, whoever threw that out there, because I was pretty sure it was 380 was cited in there. So now, Mike, with that clarification, it's been defined, and that was part of one of the reasons why ResNet developed 380, because they knew they needed ResNet wanted to have a standard that could be pointed to. And again, it's the ResNet ICC standard. It might even be ACA in there, ANSI, ACA, ICC. It might even be those guys in there too. But they all got together and said, let's do this ANSI standard 380. And that's where that definition is. So thank you. We've got it. And I'm going to add it to my presentation so that's crystal clear for everybody.
Yeah, and there's the ASTM one as well.
Yes.
Now, the follow-up from Ashley was that same building envelope testing company. Does that company need approval from the building and construction company to conduct the test in their jurisdiction?
Home builders are going to decide who they want to hire for trade contractors, and it's a straight up private decision. Okay. So, I mean, look, as a HERS rater, for 20 years. You know, my worry was working with people that didn't have the right credentials or have the right training or do the right things. But I had no control over that. The builders are the ones that defined it. Now, for Energy Star, it was a HERS rater, ResNet HERS rater, what was required. So at least we knew that you had to follow the ResNet standards for testing and inspections and doing a rating. But when it comes to code, we don't have those definitions. As I've already said, the code does not say ResNet, does not say BPI. So you don't have the backup of an organization that's overseeing its members. That's the benefit of working with an organization rather than just a set of standards. Go ahead, Mike.
Well, so she clarified to say that her question really should have read, does this company need approval from the jurisdiction to conduct a test at jurisdiction?
Almost always. Now, some jurisdictions may not, I mean, if you're in some jurisdictions, they may not, I don't want to say they don't care, but as long as they see a result, they'll be like, yeah, okay. Which I don't think you should do, but most municipalities are going to want to know who that is. And remember that in the code, it says you've got to define who your inspector is before you get a permit. So you've got to say, who is my party, who's my third party, and you've got to have approval from them. Now, what their parameters are for approval, that's up to the municipality. But you do have to have, on the 2024 code, you have to have approval before you get your permit. And quite frankly, municipalities may not be that hardcore on approval before they issue a permit. They may give you a permit and you haven't told them anything about who's your inspector yet. They may not care until they show up and they're like, hey, who did your duct test? And then you tell them and they're like, oh, okay. So some are really stringent. Some of them are pretty loose, Mike. From my experience, it's the gamut of what you're going to see out there. But you do need that approval technically per the code before a permit is issued. Permit is issued.
Yeah, and I've seen that variability here in Illinois too, where some code officials follow the spirit and letter of the code more than others, I'll just say.
Yes, 100%. That's the way it goes.
All right, so let's clear something up real quick. The question was sent in for clarity. Does the IECC now require 3 inspections, an air barrier, an installation, and a final?
So that was not, I'm not seeing that they're defined. It's the inspections as far as I'm seeing in the code, okay? They are talking about your installation inspection and air barrier being at rough-in. So those they've defined very clearly, that you need to do a rough-in inspection. But of course, they're not talking about a rough and a final. Final is when you're going to do a blower door test. Blower door test required. Final is when you could do a rough-in duct leakage test. You could do rough-in duct leakage, and that's always been allowed. So you could do that theoretically at rough-in. So, you know, Mike, I suppose you could do your duct leakage at rough. You're going to do your insulation and air barrier at rough-in, and you're going to need to come back at the end to do your blower door. So I guess you could do 2 site visits and get your inspections in for code compliance, because you just physically, you got to do those at 2 different times. Now, actually, you could do a blower door test before drywall's hung. You know, you could do that. That's not what I would recommend you do. That's not the best practice at all, but you could do that. So I would say save it till the house is done and they're about to turn the keys over to the homeowner. That's when you do your blower door testing.
All right, and then on the compliance topic, is it okay then for certificates to be accepted from Energy Star HCOs?
If when you say a certificate, you mean an Energy Star certificate? Yes.
Correct.
Okay. So remember when I talked about the pathways to get in through the code? One of those was above code program. So don't assume that Energy Star is going to be accepted by your municipality, because it may not be. Interesting story here in Phoenix. I did mention that there was a local amendment for code compliance that the city of Phoenix did. That local amendment for compliance by the city of Phoenix was a HERS index. Okay, so city of Phoenix said that you could provide a HERS index score and a HERS rating, and that would be above code. That would be not above code. That would be acceptable. Well, I went to the city of Phoenix around this time and I said, hey, this builder's doing Energy Star. Is that acceptable for meeting code? And they said, no, the city council did not accept Energy Star as above code. So no, you cannot use it as an above code program. So the municipalities have to accept it. In some municipalities, like the city of Phoenix, and the question I just gave you, or the answer I just gave you, or example, is that the city of Phoenix building code official was not going to accept Energy Star unless the city council had approved it. Many other municipalities, the building code official is going to say it's okay without approval, formal approval from the council. Because technically in the code, it says that the code official, they can define if an above code program meets the code requirements. So you've got to go to your municipality, municipal government by municipal government, one by one, and ask them, do you accept Energy Star as above code in accordance with section 104, 105, whatever, I don't have it memorized, but that section that I shared you on above code. So if the municipality will accept that, and you've told them, it says right here that you can tell me I can accept this as long as it meets these other little minimum envelope requirements, then they can say, yeah, you're good to go. Once they've approved it, then an Energy Star certificate is what you can turn in as saying, I'm compliant with the code, the energy portion of the code. Here's my Energy Star certificate. That's a long answer to a short question.
No, it's okay because it gets nuanced here. So some Energy Star HCOs also provide oversight on ERIs, right?
They do.
Okay, so then could those Energy Star HCOs in a way issue some sort of certificate that says this complies with the ERI?
Oh yeah, if they absolutely, they could do that. You bet. Because remember that in the code for testing and inspections, the last item on my list that I shared that in the slides for everybody when you get them, it says that the ERI must be confirmed by a third party, which is a HERS rater, or whoever's doing the ERI. For the HERS index, it's a HERS rater, but you've got to have somebody that's going to confirm that that ERI was done correctly. So yes, a Energy Star HCO could do the ERI path if a builder wanted to do that. I would think they would just say, let's just call it Energy Star if you're doing Energy Star, because we're already doing that. But if you were to not get approval from the municipality that would say that Energy Star is an acceptable above code program, well, then you could then flip over to ERI if you're hitting the ERI. Remember, the ERI is a pretty low number. Those ERI parameters are actually lower than Energy Star. Energy Star, you got to work pretty hard to get to Energy Star, especially the new version 3.2. But you see some of those ERI numbers; those are low numbers. You might be able to do in fact, I'm sure that you can do the R405 performance path, which your Energy Star HCO could easily print a report for you for R405. And it's not going to be, in most cases, it's not going to be a super low ERI. So I'm telling you, the simplest compliance path in almost all circumstances is going to be the R405 performance path, because it's going to give you your greatest flexibility. It's going to allow your HERS index in reality, or your ERI, to be higher than the targets for ERI, certainly, and just easier than the other pathways. So that's why so many of the builders, I always say, for production builders, it's 95% or more are doing the R405 performance path.
All right, so let's get to the hard questions now, Darren.
The hard one. All right. Everybody's being a good sport, but still hanging in there. Go ahead, Mike.
All right, and I just got a couple more questions that came in, so I don't want to ignore those too. So let me before I get to the hard ones, just another breather, reprieve here. We had a question come in from Will. He's reading that R107.2.2 as a rough-in inspection is needed before installation of air permeable insulation,
That's correct.
Would, in his mind, suggest 2 pre-drywall trips.
It depends on how you work them. I mean, if you can get in there and do your inspections correctly, if your air barrier, let's put it this way, if your air barrier is your outside skin, then you're going to need to inspect that before the insulation comes in, which means 2 trips. If your air barrier is your drywall, well then, which is what almost all of the time, that's what we define as the air barrier, is the drywall. Now you're coming out for an insulation inspection to make sure that your insulation is going to be in contact with the drywall once it's installed. Because once it's capped with the drywall, you got to know it's going to be in contact with it. So you could do a insulation inspection to make sure that the insulation is going to be full cavity thickness. It's going to be up against the drywall. But if your outside skin, again, repeating myself, if the outside skin is your air barrier, then yes, you're going to need to inspect that air barrier on the outside first. Then the insulation covers it up. And then you can inspect the insulation to see if it's correct. But again, most of the time, the air barrier is going to be your drywall, in which case you can just make sure the insulation is done correctly so that when the drywall goes on, it's in full contact.
All right, now we're going to get to the hard ones. All right.
I can't wait for these hard ones, man. Go.
So here's the question from Steve. What has been the adoption rate of the 2021 IECC throughout the U.S.? That's part 1 of 2.
Okay, so you're going to let me answer that one first. And the truth is that I do not have an answer for adoption of the IECC 2021. What I would do is I would look at one of the energy groups like SWEEP or NEEP, one of the organizations that works very closely with the municipalities on code adoption. They are great resources for you to go and talk to, and they break the country into, again, a Southwest energy efficiency product, the Northeast energy efficiency product, the Northwest energy efficiency. So there's these groups that are around the country that are very involved in the code adoptions, and they definitely can give you a clarity on what the adoption rate is for the 21 code versus the 18, 15, and even the 2024. But man, so many, I have trouble, Mike, keeping track of the adoption just in the Phoenix metro area, where we have, a dozen municipalities, maybe a few more. It's hard for me to keep track of what their adoption rate is. The Home Builders Association for us in Arizona, our local, the Arizona, basically the Home Builders Association of Central Arizona, which oversees all the home builders in the Phoenix metro area, they actually were keeping track of what the adoption was. They had a little spreadsheet that I used to get from them every now and then, and they would tell me what it is at the local level. Keeping track of that at the national level is one hairy thing to do. So I couldn't tell you, Mike, the answer to that question. Great question. Great information. You could sell that information if you had it, because it would be valuable, I think, for some people to know that.
Well, and let's clarify too, for Darren, you live in a home rule state, right? So you have different municipalities have different or can adopt different energy codes. Where I reside in Illinois, we have a state energy code that's consistent throughout the entire state.
So Mike, but let me even throw a wrench at you here, and hopefully you can answer this question. In the state of Illinois, which I do know you guys have a statewide code, I assume you're on the 21 code at this point, Mike, in Illinois. So can a municipality adopt anything other than the IECC 2021 or the 2021 code? And what I mean is, could a municipality in the state of Illinois, could they adopt the 2024 code because they're just anxious to make it happen and get out in front of the state? Or does the state say you cannot be any different than the state of Illinois? Because that's another variation where somebody could always be more stringent than the state, but only if the state government allows that.
Yeah, here the state energy code is the floor, so to speak.
Okay, the floor then.
You can go more stringent if you want to. Typically, places don't. Now, the one addition that I can make to this answer now that I couldn't in prior years is that now you have the ability to adopt a stretch code in Illinois, which we did not have that choice before. Now we do. And so the stretch code is set to go into effect here, or I'm sorry, the ability to choose a stretch code went into effect, I think, when the calendar flipped. And so that's now the option for jurisdictions. They can go to the stretch code or they can go with the base code. And so we're at 21 right now. Typically what happens though here in the state, it's a legislated thing where it says, okay, you have so many months after the most current one is published to review and adopt it.
Yep. Yep. And then I would not be surprised though, Mike, if there are places around the country, and this is pure politics, I'm sure there are places around the country where state legislatures, they will not allow municipalities to be any better than, say, the 21 or the 18 code. I can see that happening, and that's just pure politics that most people can't do much about. But I could see that happening. But I would anyway. I think we've covered that one.
Yeah, no, North Carolina is the example that comes to mind for me. North Carolina passed something that said you can't be any more stringent than the state energy code.
There we go.
And we're not going to adopt anything new until 2031, I don't think.
There we go.
So,
yep. That's just politics, total politics. Yeah.
So
and I appreciate you sharing that example, Mike. Now I've got one to actually say myself. So good.
Yeah. Now the second half of Steve's question is, and this is where it says it's hard. What do you think the adoption rate of the 2024 IECC will be?
So that's an interesting question. And what I'll tell you is that because most of the municipalities will skip a code cycle. So it's a lot of work to adopt a new code. And so to do it every 3 years is really not what the municipalities are up for, politically and in lots of ways. So I will tell you that the city of Phoenix, huge municipality, they are adopting the 2024 code. They sat out the 21 code. They skipped a code cycle. So they adopted the 18 and they said, we're not going to do the 21, but when the 24 comes, we're going to adopt that. Now, so I actually think that the adoption rate of the 24 code, if I had to guess, I would say that it's probably going to be just about the same rate of uptake as the 21 code. But again, remember that those that adopted the 21 probably skipped the 18. Okay, they probably skipped the 18, or they just, we may have some adopting the 21 code even now. But most of the time when there's a new code, they're not going to, why accept an older code? Why do that? So let's just get on the latest one so we're not further behind. So I would probably guess that the adoption of the 24 code is probably going to be about the same as the 21. And Mike, part of the reason why I say that is because I'm here telling you guys what's in the code. I'm giving you fairly detailed specifics of what's new. So if you're sitting and listening to me in my class or in this class, you're like, oh, okay. I mean, you're sitting there, you're listening to what's happening, and you've got a pretty good idea. I even threw up for you how many people that are on our call today were like me as a geek on this, just waiting for the NREL to put out the report on the, I think it was the NREL that does it, putting out the latest modeling on what the 2024 code looks like. Remember, it's like 7-point-something% better than the 21. Man, I was waiting for that report to come out, and it was released. The U.S. Department of Energy, they released it in their newsletter, and I was like all over that because I was just waiting for that so I could update my chart to say, well, where is it on the glide path to net zero? I was like a good movie. I was waiting for the sequel, right? And so I put it, like I said, I'm a geek about this stuff. So I put it on there. But I say all this to back up and then say, most people are not going to know what's the differences are. They're not going to know. They're just going to adopt the 24 because it's the latest, and whatever it is, it is. They're not going to make this big argument about, but it's going to make you do, now the requirement to insulate R3 on your pipes is also now required for the performance in the ERI path, where before it was only on the prescriptive path. We are in the weeds when we're talking about that, and most of the stuff we covered today is the weeds. Most of the people that are in class today are probably needing to be here listening to this type of an update for their professional reasons. Few of people are, and do this just because they love this, and they just want to know what's different, right? Like the sequel to the movie, like I just shared. I doubt many people are on that level. So the common people, in terms of your typical, I should say not common, but your typical building code official, they're just going to adopt what's left, and what's in there is in there. So let's adopt the 24 and go for it. I don't think you're going to have pitchforks and knives. Hey, we can't adopt the 24 because it's 7% better and it's below the line on the glide path to net zero, and man, it's asking way too much. When you look at the code and you see all those appendices added, and you see all of those options for the additional energy efficiency packages added, when you see all that, and then you say, well, I could do performance path and I get away from a lot of that. Okay, but do remember, the performance path does require 15% better now in the 24 code than it used to, and that's because that's the only way I believe the code can keep pushing you can only do so much energy efficiency. You can only juice the lemon so much. Well, we're getting to the limit on energy efficiency. And so now what they're doing is they're starting to say, give me 5% more. Just meet the code and then give me 5% more. That's what they did in the 21 code. Well, and just looking at the performance, the simulated performance option 405. Now they're saying, meet the code, which is probably baseline, not much better than the 21 baseline. It's not a lot better than the 21, but now they're not asking for 5, they're asking for 15. Or if you do gas appliances, 20. Or if you are a 5,000 square feet or more, another 5% on top of one of those two parameters. So again, Mike, I talk too much. It's a long answer to your short question, but that's what I see going on.
No, I mean, I've found with codes that you don't just kind of passively hang out with codes. You either want to be, you want to be here if you're here. That's just kind of how codes is. Now, do have a question, and this is kind of an interesting one. What if the software tools are wrong? And the context of that is we've got somebody who's had a software program tell them that mechanical ventilation wasn't required for the 2021 performance path.
I'd be curious to know, whoever that is, throw a clarification to Mike on what software we're talking about, because the HERS accredited software, Ecotrope, RemRate, and Energy Gauge, and there's a couple of more I think that are there, or ERI approved software, which may not be one of those. Yeah, usually they've got to go through what's called HERS best test, and they have to be qualified. I mean, you have to basically run a test home. They have several different test homes. Now I'm definitely in the weeds, and I'm a little out of school on this because I'm not a software provider. But being on the ResNet board of directors for as many years as I was involved in all of these discussions and approvals and stuff. What I can tell you is there's a test suite that each software has got to go through. And when you run that, a 22,000 square foot 2-story house and a 2,000, 500 square foot single family house, they've got these model homes, and you got to run all of those through the software. And you have to show a result that's within a bandwidth. You cannot be any lower than this or higher than this. So when you run these homes, they've got to be within a bandwidth to say that it's running the calculations uniformly across all the software packages. So for there to be a software package that says you don't need ventilation, man, that's a red flag to me. I don't know what software that is, but it's not going to be saying what the code needs it to say, or for that matter, maybe the Energy Star program or a HERS rating for that matter. So yeah, I don't know, but most of the software goes through some level of certification that it meets the requirements for the software packages.
Okay. Well, and the person who asked is still on with us, and basically said in a diplomatic way that they would reach out to you by email and send you screenshots. Okay. That it has been corrected. We're not going to go into the name of the software, but it was, I'll just say, one of the ones you mentioned. But it has been corrected. But there for a time it was incorrect. So
until the raters, usually it's the raters because they're the ones using this software, and the raters are the ones that will usually call it out and go, hey, because we're comparing notes or we use different software, how come it works in this one but not in this one? The bad news, Mike, the bad news is when somebody will take advantage of a flaw like that and say, hey man, my software says you don't need any ventilation, so hey, this software is accredited, go for it. Man, that's like bad news, you know, to do that. If you know as a rater or as a professional that it's supposed to have ventilation and then the software says you don't need it, and you basically go with the software because even though you know better, that's just, you know, that's just not the way to operate. But it's happened out there, unfortunately. But usually that stuff gets caught and then it's fixed right away. And then you just got to figure out, well, what about all those homes that it said it was okay for? What do you got to do about it? That's the bigger story, Mike. What do you do to fix all the ones that it said it was okay on? And we won't go there.
Right. All right, so last question here, Darren. It comes to us from Kim. He wanted to know, do you think that the new ANSI style process for the 2024 IECC development is a better process for code development versus what happened for 2021? And should the building science staff of NHB and the Home Innovation Research Lab get some credit or not? Like, so I guess first half of the question is the style of the code development, 24 versus 21. What do you think is a better approach?
So Mike, I'm going to admit to you and everybody that's in here, I don't play in the code hearings. You know, I don't do that. And so that might be a disadvantage to me, that I'm not going to every code hearing and I'm not testifying and involved in the process. So I deal with what I see in the code. I'm not involved in all of the back room discussions or even the front room discussions for that matter. I'm just not involved in those things. My focus, my time and attention on understanding what the code is and making sure that people understand how you comply with the code, what its requirements, what it's asking for. And quite frankly, if you have a subscription to the code, which ICC would love for me to say, and I have nothing to do with ICC, but if you have a subscription, an electronic subscription to the codes, you actually can get the, if you click on, go in there, you'll see these little markers. And those markers, if you click on it, it will actually tell you what the discussion was on that adoption in the code hearings. Because the code hearings, you can go on the ICC website and you can pour through all the code hearing minutes. They're all there. So if you really decide to, and I suppose my geekishness ends there. Like, if I was super into it, I would also digest all of the notes from the minutes from all the code hearings in addition to going to all of them. That would be, and there are people that are that, I mean, and I kudos to them. They are very, very involved in it. They know what's going on. I'm not going to pretend to know all those details of the discussions that go on. And it might be a shortcoming of mine, I admit, okay? But I will tell you that there are people out there that are part of SWEEP and NEEP and the other. They know exactly what's going on with those hearings and the details and why this passed and that didn't pass. And, you know, they know those details. And I would refer you to them if you want an opinion that matters. Mine won't matter on this one when it comes to defining the process that codes are created, because that's just not my bailiwick.
And I may or may not have still been awake at 1:45 in the morning watching code hearings online, and but in to continue, I mean, that was a serious comment, but a humorous comment would be, it's probably how you're keeping your sanity, Darren, because if you are to be following along with this every moment of these hearings that happen, it can be a challenge to just your sanity to follow along with it, because it is very arduous, very time consuming, and very nuanced, I'll say.
I, Mike, prefer to think of it more as a practitioner than the person that's creating the code itself. Like I told you, several code cycles have gone by, and I want that duck testing language to be the same. It's the the part of me that wants everything to be uniform and correct. I want that one sentence to be in there for the duct testing. It's not that hard, but you know, I just have not felt it was so important that I needed to put a comment in. I almost did this year for the 24 cycle. I was like, man, I don't have time for that. So I'm more about teaching and practitioner and doing that than the detail. But God bless the people, right, that are doing that hard work of code adoption. That is hard work. And there are real true experts at that know the nuance and the details. And I give them every ounce of credit that they deserve for that hard work. It's easy to be an armchair quarterback, right? And maybe I play that role. Maybe that's me. I try not to throw stuff at the process because I'm not the one that's doing it. I try to deal with what I've got. Okay, this is what they're requiring. They got all zeros in the table for the lighting option. I think it was. They got all zeros in there, but who am I to say that was right or wrong? I don't know why they did it, but that's what we're looking at. So I'll leave it at that and give those guys their due credit, guys and gals.
Yeah. All right. Well, that is all that we have for today. I want to thank Darren for not just the presentation, but the about equal length time of Q&A. You know, I find when we do a lot of codes webinars that those are the most inquisitive groups, just because of the nuance and because of how much content is there. So thank you for fielding all the questions that came in, Darren.
Of course. I hope I've been helpful to everybody in the information I shared and the answers that I was able to provide.
Yep. And for those who were having issues with accessing the Dropbox, we did share a link in the chat. Also, we've got Darren's email address in there that you can check out as well if you want to reach out to him privately. But thank you very much to our audience for attending, asking all those wonderful questions. Thank you to PowerShift by NV Energy for their consistent and continued sponsorship of these types of webinars. Now, for those who have registered and for those who haven't registered yet, a new year means new Housing 2.0 workshops. We're back with new topics and guests, and instead of a series, we're actually going to spread it all throughout the year. And all that fun starts next week. So please join us on Thursday, January 23rd at 2 p.m. Eastern Time. For more information and to register, please go to greenbuildermedia.com/housing-2.0. Thanks again for joining us today, and I hope to see many of you next week. Until then, stay safe, stay healthy, and take care, everyone. So long.